Guru Gobind Singh, uh, located in the heart of Kalkaji, New Delhi. We are affiliated to Guru Gobind Singh Indraprasth University, New Delhi. The institute continues to focus on academic excellence, research innovation, and industry oriented learning. Banarsidas Chandiwala Institute of Information Technology, established in 1999, operates under the aegis of Sri Banarsidas Chandiwala Seva Smarak Trust. The trust is a charitable organization serving since 1952, and our eminent college offers a 2-year MCA program and 4-year BCA program. Before we start, we would like to familiarize you all with the vision, mission, and achievements of Sri Banarsidas Chandiwala Seva Smarak Trust Society. We would like to showcase a brief video presentation to you all. I request our co-coordinator, Ms. Sonia Batra, to please play the video for the audience. Thank you, Sonia ma'am, for playing this video. And we feel very regret that there was a bit network issue. But I would like to share that the Banarsidas Chandiwala Seva Smarak Trust Society has been started in 1952 and is running at present 5 institutions: Banarsidas Chandiwala Institute of Information Technology, that's our college, and Banarsidas Institute of Professional Studies, Banarsidas Institute of Physiotherapy, and Banarsidas Chandiwala Institute of, Banarsidas Chandiwala Institute of Hotel Management, and Janki Devi Memorial College. Janki Devi Memorial College is affiliated to Delhi University, and other 4 colleges are affiliated to Guru Gobind Singh Indraprasth University. On behalf of our director, Professor Dr. Ravi Sagar sir, and the organizing committee, I extend a warm welcome and cordial welcome to our distinguished resource persons, research scholars, faculty members who have joined this FDP program from various institutions across the country. Thank you so much for joining us. Could you please, Sonia ma'am, confirm me once that I am clearly audible or not?
Madam, you are very much clearly audible.
Okay, thank you so much, sir. So we feel proud and honored to be among the 300 institutions selected nationwide by the Atal Academy to organize this faculty development program. This opportunity is a testament to our institution's academic excellence, and it is a credibility and commitment to the excellence. Furthermore, having successfully conducted an Atal sponsored 1 week FDP last year, we are motivated to continue our efforts in fostering quality faculty development initiatives. In today's fast evolving digital era, cybersecurity has become a critical global challenge. The integration of artificial intelligence in cybersecurity is redefining how threats are identified, detected, and mitigated. This FDP aims to provide insights into emerging trends, advanced tools, and research directions in AI powered cybersecurity, benefiting both teaching and research communities. This program has been designed especially for faculty members and research scholars to enhance their technical expertise, strengthen research capabilities, and support innovative teaching practices. I'm confident that the sessions over the coming week will foster meaningful discussions and collaborative learning. I would like to briefly mention the efforts of the organizing team. The program is being supported by the co-coordinator, Ms. Sonia Batra, along with our technical team, Mr. Amit Srivastav and Mr. Mitendra, and the student coordinator, Ms. Haripriya from MCA first year, who are ensuring the smooth conduct of this online FDP. On behalf of the entire team, we would like to welcome all the participants once again. I also acknowledge the guidance of the Atal Academy and the contributions of our esteemed resource persons for the first day of the FDP, Professor Dr. A. Mohapatra and Dr. Indranath Chatterjee, who will be sharing their expertise throughout the program. I encourage all participants to actively engage in the sessions and make most of this learning opportunity. With these words, I welcome you all once again and request our esteemed director, sir, whose visionary guidance has shaped this program, to formally inaugurate this first day of Atal Online 1 week FDP on emerging trends in AI powered cybersecurity and address the gathering. I request Dr. Ravi Sagar, sir, to please take over the session. Uh, Amit sir, please check, do we have Ravi sir in the meeting? Or maybe he's finding some technical glitch, I think. I can see him in the participant list, but I think he's finding some technical glitch.
है मैम, सर तो हैं अभी मीटिंग में ही है।
सर उनको शायद माइक का कोई इशू आ रहा है, एक बार प्लीज कनेक्ट कर लीजिए।
माइक की परमिशन है मैडम। हेलो सर।
Let me check out, ma'am. Let me check out.
ओके मैम, ओके मैम। Give us a few more minutes. Sir is maybe he's finding some technical glitch. He is rejoining in few seconds. So thank you so much for your patience.
Due to a technical glitch, our worthy director sir would be able to join back in another 2 to 3 minutes. Thank you everyone for your patience.
Hello.
Yes, sir, you're audible, sir. I once again invite our esteemed director, sir, to formally inaugurate the 1 week FDP, Emerging Trends in AI Powered Cybersecurity. Sir, please take over the session. Sir, you're muted. Please switch on your mic once. Muted.
Am I audible, ma'am?
Yes, sir, sir. Yes, sir.
Yes,
Please
sir.
continue, sir.
Okay. Sorry. Extremely sorry. Cybersecurity is much more than an IT issue. It is a business and social imperative. Good evening, everyone. It is my privilege to welcome you all to this faculty development program on emerging trends in AI-powered cybersecurity. We stand at fascinating crossroads in history. Technology has given us incredible power, the ability to connect across continents in seconds, to analyze vast oceans of data, and to innovate at a pace humanity has never seen before. Just with this power comes vulnerability. Every click, every transaction, every digital footprint is a potential target. Think about it. A cyber attack today can shut down hospitals, disturb financial systems, or even manipulate democratic process. It can even lock your data and demand a ransom for its release. On daily basis, we are hearing news about cyber fraud happening. These attacks often involve stealing personal and financial information and illegally obtaining money through various schemes such as phishing, malware infections, fake online sales, and sophisticated business email compromise scams. These threats are harming people and business everywhere. Cybersecurity is no longer about protecting computers only. It is about protecting lives, trust, and the very fabric of society. This is where artificial intelligence steps in as a force multiplier. Imagine an AI system that learns the rhythm of your organization's digital heartbeat and instantly spot when something feels off. Picture algorithm that can predict an attack before it happens, much like weather forecasts warn us of storms. Consider automated defense that respond in milliseconds, far faster than any human could. These are not science fiction. These are happening right now. AI is transforming cybersecurity from a reactive shield into a protective guardian. In 2017, a WannaCry ransomware attack crippled organizations worldwide, including healthcare system in the UK. Traditional defense struggled to contain it. I would like to share with you a popular AI-based cybersecurity example. You must have heard one recent advertisement by one famous network provider company which focuses on the safe network, an AI-powered system blocking scam links and spam calls, reassuring users with the tagline, "Kuch nahi hoga," nothing will happen. This campaign highlights how their network automatically block dangerous websites across apps like WhatsApp and email, protecting users from financial fraud with features like real-time alert and link blocking. All this at no extra cost. AI-driven system can detect such anomalies in real time, isolating threats before they spread. This is the difference between chaos and resilience. it is very important to proceed carefully, even with the AI support. Adversarial attack can trick AI into making wrong decisions. Data privacy must be protected as AI consumes vast amount of information. Ethical question arises. How much surveillance is too much? Who is accountable when AI makes a mistake? The future will demand professionals who are not just technologists, but ethical leaders, people who innovate responsibly, ensuring that progress never comes at the cost of trust. To all of you here today, you are not just participating in a program, you are architect of the future. You will train the next generation of cybersecurity professionals. You will shape policy, research, innovation that define how safe our digital world will be. And you will carry the responsibility of ensuring that AI remains a tool for protection, not exploitation. Remember, cybersecurity is not about machines. It is about people. It is about safeguarding dreams, business, and society. With AI as our ally and with responsibility as our compass, we can build a digital future that is both secure and human. This FDP aims to equip you with insight into these emerging trends, practical application, and research opportunities in this exciting domain. I encourage all participants to engage actively, share ideas, and make the most of this learning experience. With all this, thank you, and let us begin this journey into the future of AI-driven cybersecurity. Thanks. Now I request coordinators to take charge and proceed. Please. Thank you.
Thank you so much, sir, for sharing your insight. Uh, Now we are starting our first session. So I would like to introduce our resource person to all the participants. We are privileged to host Professor Dr. A.K. Mahapatra, a distinguished academic and expert in the field of information technology. Sir is currently serving as a professor in the Department of Information Technology at Indira Gandhi Delhi Technical University for Women, New Delhi. Professor Mahapatra brings a wealth of knowledge and experience to our event. Previously, he served as an associate professor at University School of Information, Communication and Technology, Guru Gobind Singh Indraprasth University, Delhi. And he also worked as the CTO and Chief Information Security Officer of Delhi Police, where he established groundbreaking initiatives such as Center of Technology for Police and the Cyber Cell. Sir is also member of various committees of Government of India like Safe City Project, ITMS, Nationwide Honeypot System. Sir holds a PhD in IT from Guru Gobind Singh Indraprasth University, Delhi, and has an impressive research portfolio spanning cybersecurity, deepfake investigation, cyber threat intelligence, cryptography, and quantum cryptography, with over 120 publications in reputed journals and conferences, including ETT Ville, IEEE IoT Journal, and Computer Communication Elsewhere. He is a prolific contributor to the field. His accolades include 3 Indian patents and leadership roles as PI of 2 funded projects. As a session chair and reviewer for esteemed journals, Professor Mahapatra continues to drive innovation and research excellence. I would also like to mention that Sir has a consultancy project of approx 9 crore. He is also member academic. He's also member of academic council, doctoral research committee of Jamia, DU, IGNU, as well as Guru Gobind Singh Indraprasth University. Under his supervision, 7 PhDs has been awarded and 8 are currently doing their research work. Sir has been conferred with University Best Teacher Award for 2006 to 2007 and as Career Guru in 2013. Sir, we feel privileged to have you on board with us as a speaker of the first session of this FDP program. On behalf of BCIIT, organizing committee, and all the participants, we extend a warm welcome to you and request you to please take over the session.
Thank you so much, ma'am.
Welcome, Mahapatra sir, and we are honored to have you with us today.
Thank you,
Welcome,
Ravi
sir.
sir. Thank you, sir. Thank you, Director sir, madam, and dear participants. I hope that I'm audible.
Yes, sir.
Yes, sir, you're clearly audible.
Just I'm sharing my slide. Actually, the topic that has been given to me, that is introduction of AI, ML, and cybersecurity. Because you see, I have worked with Delhi Police, and particularly I have established many cases, as well as Center of Technology in Policing Cyber Cell. And but my research is on cryptography, which is actually the basics of cybersecurity. But I have prepared introductory on cybersecurity, and let us share my screen, sir. I hope that it is visible to all of you. Is it visible, ma'am?
Yes, sir.
Yes, sir, it is visible.
Okay, this is how I have managed. I mean to say that I have prepared because we need a motivation why there is a cybersecurity lecture and why we need FDP, particularly on cybersecurity. Therefore, what are the major cyber attacks that is in India, which is published? Actually, there are many unpublished cyber attacks. Because of certain reasons, it has not been publicly available. But however, whatever being notified here, that is from the public sources. During 2025, I'm not talking about 2017, 18, 19, 20, but I'm having a basic landscape of cyber threat that has happened in India, in a globe, particularly from the last 10 years, that I will be discussing for 2 minutes. Then key AI driven, because you see the advent of AI, then AI can be used as a cyber weaponization of cyber attack, or it can be of defensive purpose. Therefore, that part I will be taking, that how AI can be driven for cyber attacks. Particularly, the government of India is now struggling, particularly in the recent cyber attacks of ransomware, what sir has already been described. One such cyber attack occurred in AIIMS Delhi in 2020. Then 2024-25 also, there are so many cyber attacks occur. Then I will be discussing some of the basics of cybersecurity, land threat landscape. Then top 10 AI-enabled cyber attack. Then we'll talk about the AI-ML basics and applications of AI-ML in cybersecurity, particularly the Security Operations Center, where actually I have worked in Delhi Police for establishing the intelligent traffic management system, as well as the Safe City project from the Nirbhaya Fund. That because there are two use cases that I will be given how AI/ML can be taken, as well as in the recent landscape how AI/ML has been driven to the cyber security as a defensive purpose. That is only I'm talking about some of the few attacks on 2025. Briefly, let us discuss one by one. These are actually some of the prominent cyber attacks that has been publicly available. That has happened in March 23rd to I think December 25. You see, the last one is called AIIMS Delhi ransomware recurrence attack attempt. If you recall, in 2019-20, the AIIMS is actually called a critical information infrastructure, because you see, our health sector is health sector, education, and stock exchange. There are some of the infrastructures that comes into the category of critical information infrastructure. And our AIIMS OPD system has been paralyzed by a ransomware attack in 2020, and people has encrypted the, I think, the file, or what we called the data center, what we called. Actually, it was not a data center. It is actually the server of the AIIMS, and no OPD online system has been taken care of for 1 month. I mean to say 1 month actually they took to neutralize the ransomware. The question is, in India, country like India, and the top institute of healthcare, AIMS, has been paralyzed by an attacker, and it took us around 25 days to neutralize. That actually, you see, if this type of attempt occurred to our, let us take power grid, let us take other, I think, service providing agencies, then that is nothing but a disaster. Disaster actually, what I mean to say, you see, most of the critical infrastructures now is being managed by a computer or a computer related process. Therefore, manually operations again need some time to take care. Now let us, the post Operation Sindoor, whenever there is a physical conflict, that follows by a cyber conflict. And you see, no Operation Sindoor, and you see after that, no doubt our neighboring countries, Pakistan, and there are some other, I think, countries they have targeted to our critical information infrastructures. Then Bombay Stock Exchange, activist denial of distributed of attack, DDoS, denial of service, particularly distributed denial of service attacks on Indian organizations, India Cyber Force offensive operations that I should not discuss here. ICICI Bank vendor portal malware implant, DRDO spear phishing campaign, sought in alert on operations Buya al Marisas, dance of the Hillary malware spread. These are actually whatever it is being written. There are some of the, I think, major attacks that occur in 2025 in India. Then if you go to the details, you see most of the things they are targeted our critical information infrastructure. You see our Aadhaar, UIDAI services, our AIMS, the healthcare, DigiLocker, that is called National E-Governance Division, and that is called major stock exchange. Then Operation Sindoor, that's actually they generally targeted most of the critical information infrastructures, banking sector, and some of the health insurance, Star Health, actually one of the largest health insurance of India, and their data has been breached and that was stolen, as well as a threat has been given to the CEO of the data health center, because you see massive data breach occur. So that motivates that we generally, because I'm not talking about the, I think, individual level of cyber criminal, like digital arrest, and you see the cyber frauds occur during OLX, and there are many, I think, some job portal, matrimonial, the pretty, I think, cyber crimes that I'm not talking. I'm talking about the cyber attacks that is governing to our nation's critical information infrastructure. That is the need that the topic is very much relevant, and Government of India is actually spending crores of rupees for cyber education awareness. And I am thankfully, we are a participating Institute of Information Security Education Awareness, which is called ISCA. Please go to the isca.gov.in. You can have massive information about your cybersecurity educations and the courses, syllabus, videos, trainings, and your students, even if for intensive internships to the BTech and MTech students, the government is providing scholarship. Even if in the university itself, we have, I think, hiring interns with paid interns, and we are paying 20,000 per month to the graduate students. So that's actually one of the, I think, motivation and relevant topic for today's world. That is the reason that perhaps this topic has been chosen by the organizer as well as supported by the AICT. Okay, let us come by one, because we understand the cyber attack campaign. Followed, then once we know the motivations, then we discuss about, I do not know the backgrounds of the participants. Those who are already been acquainted with cyber forensics or cyber security, they might be, I think, that seems to be, I think, very much familiar. But those who are not actually a cyber security experts and are not familiar, please try to understand what I am talking about. That is not individual cyber offenses that is targeting individuals, like digital arrest, like you see, I mean to say, deep fake and also image morphing and also certain things. I'm talking about the attacks that occurred by our state agencies to targeting to our critical information infrastructures. You see, first incident occurred that is called post-Sindoor operations. Over 1.5 million cyber attacks targeted 1.5 million in 2 days. Indian websites following the Pahalgam terror strike. That means it is not the individual, there is a group of people supported by the state agencies. There is a cyber wing or a cyber soldiers that is being recruited by the government agencies of our neighboring countries. Similarly, the question comes whether India has that. We actually built our nation or built our capacity building in cyber security to make some offensive strategies. That what is being over 1.5 million cyber attacks targeted Indian websites just after the Pahalgam terror strike. 7 advanced threat groups. What is APTs? You see, they are very much skilled and they are well acquainted with the tactics, and they have the standard procedures and they have the right technologies. They are primarily linked to Pakistan, Bangladesh, Indonesia, and the Middle East, identified as the cyber, I think, APT threat actors. The attack succeeded, aiming at the critical infrastructures, including government, banking, and healthcare sectors. They attack because these are the 3 critical infrastructures where the country's backbone is residing. You see, if my banking sector is being paralyzed for even if 1 day, what is actually the massive loss that a country will occur? Similarly, if my stock exchange is being paralyzed for 2 days, then my economy, you see the massive economy loss that a country bear. And if you see the critical infrastructures like electricity, water pipeline, and everything, even in the airport, railway, if that is being paralyzed for 1 day or 2 days, or even if 3 days, that means what actually. Therefore, cyber, I think it is earlier it was cyber attack, cyber crime. Now it is cyber terrorism, cyber disaster, and we think a cyber warfare in that context. Dance of Hillary, that is another malware. I mean to say, they generally wanted to steal almost all informations. There is a PDF or this is actually the modus operandi is as usual. That is very much old. And that occur also. That what happens, you see, Pakistan linked malware campaign named Dance of Hillary. Hillary Clinton is actually dancing with a pose, and if you click, then they significantly data breach has been occurred. That warning is issued by the agencies, particularly that reported by the Punjab police. That is in 2025. Star Health data breach and threats. You see, Star is an insurance company, health insurance company, and the data is actually that is called 7.25 terabytes of sensitive personal medical data from the Star Health that has been stolen. Zenzen is actually, they claimed that they have leaked the data and threatened the CEO of the Star Health. This data is publicly available. That is nothing secret. What I mean to say, there are many things which has happened, perhaps might be happening to other sectors, which is not being reported. Affected over 31 million customers. Hackers sent death threats and bullets to company executives. Bombay Stock Exchange advisory, that was attempt and the sort-in that came into the rescue, and it was targeted to ongoing cyber threats linked to Pakistan, targeting India's banking and finance sector. Operation Sindoor, cyber fraud going exposed in Bihar. Actually, a cyber fraud gang operating from Bihar exposed. Gang used over 2,200 bank accounts, each used only once to avoid detection. Again, it was linked to Pakistan. Telangana cybercrime network bust. I'm just giving a very overview. I do not want to deliberate the modus operandi. As a researcher, we first analyze how it has happened. The happening can be, I think, to exploit some of the vulnerabilities. If we classify the vulnerabilities, we have three main vulnerabilities. One is called, first of all, for general citizen, it is a policy related vulnerabilities. For example, in your university, you have a policy, whether is it implemented properly, first of all. Then if it is, why it is not implemented? But there is a science, or there is a psychology behind that. Perhaps who cares these things? मेरा तो नहीं हो रहा है, क्या होगा? दूसरी बात है कि ठीक है, पासवर्ड ब्रेक होगा तो क्या होगा? हमारी डाटा का कोई वैल्यू नहीं रहता. Or users acceptance is one of major criteria where the policy is not being implemented. I told that a password to be, I think, like that. The pen drive should be used in that way, but it requires a proper, I think, users acceptance policy is one of the cornerstone whether the policy to be active. Therefore, policy vulnerability related to policy is one of important criteria where actually people are exposed. Second will be technology related vulnerability. For example, if I am using a old language like C language, C++, and if I am using a Java language, the two difference will be the, you see, the Java language we have, I'm giving an example what is meant by a technology related vulnerability. We have an array out of bound index mechanism in Java, whereas in C, C++, we do not have an exception handling criteria. Therefore, if I initialize thereby, there are certain attacks occur in C, C++ language. You can Google out. One such attack will be SQL injection or buffer overflow. Whereas in Java, we do not have the concept of buffer overflow. Therefore, generally 10 years back, my website or my software is being written in a particular language. Why I need to update? Because it requires money. Who will give us the money? Therefore, that is I'm using an old technology and which is full of vulnerabilities. Still, I'm using it. That is one of the vulnerability, technology related. The third one is called your platform related vulnerabilities. For example, because you see that is a cloud as a platform or operating system as a platform. I'm hosting my website in a unpatched operating system. Let us take Windows. And you see, I'm seeking that my website will be very much safe. And there is a, I think, there is a policy that the audit will be occur in 6 months. For the auditor takes 15,000 per a particular audit. Therefore, who will provide the funding? So that is the reason that there are categorically three types of vulnerabilities which generally being exploited for a cyber attack. That is the reason that we must have a vulnerability. That is one of the vulnerability is being exploited by the attacker to defend. And I'm talking about the prominent cyber attack that is called Telangana Cybersecurity Bureau conducted a 10-day operations in Gujarat, arrested 20 individuals, including a banking manager for involvement in a cybercrime network. I think you can Google it out. My slides may be available to all of you. If you want to understand the modus operandi and the more details on these attacks, you can get the details of how generally have an attack. You can make a research on that. You can make a white paper or a research paper, or you may analyze the various modus operandi, and you can take I think a countermeasure how these attacks can be prevented in 2026. Activist DDoS attacks on Indian organizations, that is another way. Surge in DDoS attacks launched in activist groups across sectors aimed at disrupting services and drawing attention to political grievances. That is again a website related attack. I'm not going to the details. Nippon Life India Asset Management cyber attack. That is actually targeting one of the organizations. That is financial sector cyber attacks. You see multiple cyber actors on Indian financial sector prompted the Reserve Bank of India to caution lenders and introduce secure domain names. App 36 espionage threat is a Pakistan linked group targeted Indian defense networks with Crimson Rat, that is called remote access Trojan malware. Particularly Trojan is one of a malware that is used to steal the informations. I'm not talking about that is the honeypot type of what we call honey trap type of thing, but somehow this is a Pakistan linked group which is actually targeting leveraged of emotionally charged, that is called Pahalgam attack. ICICI Bank vendor portal malware implant. I'm just naming it few so that these are the, I think, malware discovered by a compromised third-party vendor portal aimed at accessing internal processes via credential harvesting. That is our Aadhaar targeted in DOS attack. The DOS attack briefly affected Aadhaar authentication services launched by a regional activists. No breach, but availability compromised. DigiLocker API exploitation. You must have heard that. That is a very important, I think, news in the month of July. That token validation was the issue, but somehow it has been patched quickly. DRDO spear phishing campaign that was occurred again. A Pakistan-backed group sent malware infected PDFs to DRDO researchers. Data exploitation attempts. But DRDO is one of a critical research organizations of Government of India. Therefore, the scientists have already been targeted by some state-sponsored agencies to understand, to get the information of our defense research. Central Bank of India phishing infrastructure compromise. That is another attack that occurred in again in the month of perhaps in October. Then AIMS Delhi ransomware recurrence attack. I'm just giving because I was a part of Delhi police when that attack occurred in AIMS. You see, it took around 25 days to do, because you see, perhaps there are that might be to so many. I think you see once, because that is a disaster management. I mean to say, they must have once a data center is there, that is a disaster recovery. Parallelly, there is another data center. I mean to say, if one of the data center is being compromised, then the services cannot be hampered. But in spite of a proper data storage and data backup, why it took so many days? The reason perhaps it might be because the path where actually the attack came, that need to be identified. Otherwise, what happens? Suppose I can again restore the things with my stored I think website. That what happens? You see, the next time again there might be same attack path, a same attack methodology. That again another crisis will happen. So that is the reason they have measured a depth of defense layer to revamp the infrastructure, and it was recurrence attempt, but however it was been neutralized in because follow-up intrusion attempt on AIMS servers post 2022 breach, but blocked early confirmed cyber attack targeting hospitals IT infrastructures. Certain alert on operations Bonian al Marsas targeted APT advanced persistent threat campaign allegedly from Pakistan targeting India's critical infrastructure, our SCADA systems and OT networks. That is a cryptocurrency exchange hacking, and that is actually what we called, that is the motivations why we need actually a cyber security awareness and cyber security research, why we need a capacity building on cyber security. Particularly, that is the reason that you see in 2025 there are some attacks that I have mentioned. There must be so many other attacks which must be available. I'm not talking about the personal or targeted attacks to individuals or organizations. I have talked about how our critical infrastructures that has been targeted. Then you see exponential growth of sophistications of cyber attacks. Now I'm talking about the applications of AI. AI, I'm talking about being used as offensive, not as defensive mechanism. Cybersecurity, because you see how AI can be. I'm having a paper on a Mirai attack. I mean to say how we can. I think one of my PhD scholars, he completed a PhD. How a paper malware can be used, identified by a AI-enabled mechanism. That is called your defensive purpose in a pros sense. But in a negative sense, how AI can be used. Cybersecurity involves technologies, processes, and practices to protect systems from attacks, damaged or unauthorized access. The increase in interconnected devices and digital infrastructure has led to complex cybersecurity challenges. Actually, when I think the director sir was discussing, he told that 2017 there is a WannaCry. And if you talk about 2010 years back, 2007 and 2017, and your pre-corona and post-corona era, the cyber security, the attack has been surged exponentially. It is because the increase in interconnected devices, the induction of IoT, CCTVs, and so many IoT devices to our digital infrastructure has led to complex cybersecurity challenges. Because you see that we talk about the cybersecurity of data center, I talk about the cybersecurity of our network, but what is the cybersecurity of the endpoints? Our mobile phone is being connected to our data center, but we have enough layered security mechanism on the top layer, but what is the endpoints? That is what we discuss about. Nation, state, and criminal adversaries continue to evolve. You see, I've already discussed our enemy countries. They have been recruited by the government to take cyber attack to our country. Therefore, earlier it was talk about the cyber crime. Now we talk about the cyber terrorism disasters that will be sponsored by the nation state and adversaries. Therefore, the impact of cyber attack is much more what actually 5 years back or 2 years back. And dynamic intelligence-driven cybersecurity is necessary for real-time assessments and continuous monitoring. The fourth part, that require a AI-enabled cybersecurity monitoring. And the first part, they talk about cyber security is an issue due to how AI can be used negatively. There is a framework where actually we have many cyber security frameworks. One of the important cyber security organization that is called NIST. If you talk about any guidelines, compliances, the NIST comes to the first front. The NIST framework provides a structured taxonomy to understand cybersecurity solutions. Therefore, anybody who wants to understand cybersecurity on more detail, they are advised to go to the NIST website, NIST. You please go through the NIST, various attack parameters, the frameworks, incident management, applications, and many things that you will be, even if some certification that will be provided by the NIST. However, it includes 5 core functionality. You protect, detect, respond, and recover. Therefore, it is generally based on these 5 principles. And if you talk about AI is one of the criteria, then in almost all steps, AI can be taken into account. These functions encompass 23 solutions categories relevant to improving cybersecurity. Therefore, dear participants, since due to the time limitations, I am not going to the details. If somebody wants to do a research on cybersecurity resilience framework or risk management, or suppose if somebody wants to talk about incident handling, incident frameworks, they are required to go to the NIST cybersecurity framework in detail. Just like NIST, there are numerous frameworks available, but however, NIST has been taken as one of the benchmark framework for these topics. Artificial intelligence, actually, as you know, because the topic which was being given to me, that is introduction to artificial intelligence, though I am not an expert in AI, ML or DL, but however, it has been extensively used. I am using AI in some of the cybersecurity mechanism. Therefore, the domains and applications that includes intelligent behavior by analyzing environments and acting anonymously to achieve goals. Core AI domains include reasoning, planning, learning, communication, and perceptions. I'm talking about the role of AI in cybersecurity that includes knowledge presentations, optimizations, NLP, and computer vision. I'm talking about one of the computer vision. There is a problem. What you see that, for example, you see before a ransomware attack, before a cyber attack, my computer image is like that. But after an attack, the image has been changed like that. Therefore, can I just scan the image in the, what I mean to say, just by after an attack, can I make a model that just it observes the image of the memory and identify which class of cyber attack it occurred? That is a research, and you see that is a, I think if this problem will be solved, then many of the solutions that come to the picture. You got it, what I mean to say. For example, prior to the attack, there is a normal image of my memory, hex image. After the attack, this is my, suppose a memory has been given to you as input to the system, and it identifies at the output that yes, there is a cyber attack occur under this category. Therefore, what we called that is called computer vision can also be taken as research in cybersecurity, that is called memory proliferation ideas. Okay, that is identify asset management. Therefore, AI can be used in governance, risk assessment, risk management, business environment, and asset management. I'm not going to cover the details. And protect, and you see there is a 5 layer. One, the second layer is called protect. Therefore, identity management, authentication, access control. I'll be describing what does it mean authentication, what is meant by access control, identity management in the consequence slides. But AI supported user authentication utilizing physical and behavioral biometrics for user authentication. AI supported device authentications and automated access control, role-based and attribute. Then adaptive security awareness and training, personalized cybersecurity training and recommendations. Therefore, these are the some of the, I think, applications from the protect domain of NIST framework, where AI has been used. Then for detect anomalies and events, intrusion detection system, if you go to the scholar.google.com, then you find out IDS or NIDS, network intrusion detection system or intrusion detection system. If you click, then you will find out thousands of papers that will be being published based on applications of ML based IDS. Therefore, you see anomalies and events, that is being one of a major criteria where generally we can use ML for that security continuous monitoring. There is a concept called security operations center. Sometimes that is called SOC, SOC bolte, SOC analyst. That is, I think, a broad word in cybersecurity domain. SOC and NOC analyst. NOC means network operations center, and that is called SOC means security operations center. Where actually you see there are, I think, thousands of networks, and in one room, the AI can actually flag what type of attack that is occurring and what is actually the things. Therefore, AI plays a very important role for security continuous monitoring in a SOC operation. Then detection process, dark web investigation, sentiment analysis, and threat intelligence from dark web forums. Detection process. Let us actually, I think, talk about some of the, I think, that means how AI can be used as, I'm talking this slides as how AI can be used as actually in the offensive parameters, means how it has been generating hyper personalized phishing at scale. Then hybrid human AI operations, particularly in the buzzword today's world, that is what we call generally for example, autonomous computing. That is a, I think, a more area. You see, let us take your, I think, you have a solutions for a cyber attack. For example, I think, let us take a, I mean to say, let us take a antivirus techniques. But you see, the code itself, I think, learn itself and proliferate into another code, what is called a code cloning. Then what happens? My strategy can be difficult to understand. Again, these are actually some of the frauds that is being happened due to AI, execution of impersonations, live video deepfakes, impersonate CEOs, CFOs, trusted clients during real-time calls. I mean to say, suppose you see, I'm in UK, and let us take, I am the CEO of organizations. I call to my accounts manager that, okay, send 2 lakh rupees or 2 CR to one of my friend. Therefore, you see the deep fake, the tone remains same, the picturization remains same. Therefore, the chief finance officer particularly may not, I think, because the CEO has demanded, the chairman has demanded some money. There is no way to, therefore, this is one of the executive impersonation. That is what we call. Therefore, there are many, I think, frauds that has happened later on. I think it has been found. I will discuss what is the, I think, the challenges of the police to investigate. That is another challenge. Why actually? Because the money has been transferred to the account, and in spite of all such things, why I think police cannot able to find a solutions for that. Romance and investment scams, AI generated fake personas build trust and manipulative victims. You see, matrimony fraud is one of the biggest problem in actually there's a KYC bypass, deepfake videos, and image trick identity verification process. Criminal specializations in impersonation as a service. Vendors providing deepfake as a service and recruitment AI video actors. The dedicated deepfakes are therefore deepfake. I will be covering some of the solutions. Deepfake logo is another, I think, problem, and one of my students is doing research on that deepfake logo. You see, the logo has been deepfaked, and what is the solutions for that? That is a, I think, research area where you can, I think, take a research on that. AI assisted scam call centers, text to voice and synthetic voices, inbound AI voice responders, and SIP based call center platforms. I think because there is a time limit, I do not want to discuss in details, but these are actually some of the, I think, AI assisted scams, or AI is used in a negative purpose to assist cybercrime. Unrestricted Gen AI chatbots, dark large language models assisting in fraud and scam content generation, crafting, phishing kits, malware and exploit development support, self-hosting preferences, jailbreak models, use case specific fine-tuning, developer-centric features. Just I'm giving a limelight particularly. Then how it has happened, what of the things, therefore you click on the photo and you have a Google on that, or you can have a chat GPT on that, then you will find out the details models. Now you see, people talk about the AI in cybersecurity. I mean to say, how AI can be used as a cybercrime, as a method, as a service, and how AI can be used in cybersecurity applications. Next generation firewall, I think the malware analysis by AI, tremendous application is there. Even if AI is used to detect a fake defect, but you see, I'm not talking about the security in the AI models. That is a new research area is coming of data poisoning. I mean, the model has been trained to predict if the model data is being corrupt. That is a disaster. That is the reason that security in AI is a new research and a hottest area in the security domain. Everybody talks about how cybersecurity applications can be using AI. Or somebody talks about how AI can be used in cybercrime. But now I'm talking about another research that is called some things that is called data poison. If the model has been poisoned, if the model data has been corrupted to provide a wrong predictions, where everywhere cybersecurity models, AI models has been used to provide a recommending system, to provide a predictive system, to provide a proactive systems. If the model is being corrupt, if the data that is being trained or that is being used by the AI model, if that is being corrupt by certain things, that's called data poison, then how the model will behave. That is actually a research topic recently, or that is a new hottest area in cybersecurity domain, particularly that is called security of AI models. Now I'm talking about the opposite part, how this cybersecurity is being using AI ML. The earlier part, that is actually the AI has been used particularly offensively in cybersecurity. Now I'm talking about this way, that AI in using in a positive sense, how it is helpful for cybersecurity mitigation. AI in cyber attack mitigation, not cyber security mitigation. AI in behavior threat detection. Then security operations center, I talk about SOC efficiency and response automations. threat intelligence and proactive defense. Now every organizations have a threat intel model. Communication content threat detection, financial risk mitigations, vulnerability and patch management. The most recent developments in AI power, because you see the smart city in almost all developing countries and developed countries, they have a smart city concept, because everywhere there is a AI enabled what we call CCTVs. In Delhi particularly, 3 lakh CCTV cameras that is being deployed by government of Delhi, and 10,000 CCTV cameras for surveillance proposed by Delhi police. And we are not counting the CCTV cameras that is being used by the residential RWAs, right? But you see that because most of the CCTVs that is being used by the government purpose, that is being linked to a cyber center, and particular data center is being managing these things. Now I'm talking about that how generally, suppose you see a chain snatch event is occurred, therefore why can we apply a AI built model that the camera can detect and provide a proactive solution, which is actually a problem in Delhi cities. Similarly, there is a fire incident occur and somebody had detect and call a dial 101 for a fire emergency, because my camera itself detect, and through a vision AI component, it itself detect and provide an alert to the 100 instead of a human intervention. So that is how we can say that AI very much useful in so many other ways. That actually, you see, I'm not going to discuss about the threat detection model, because there is a time limit, because there are so many other things I have to cover. Smart city deployment, you see AI in IoT and OT security, that I have given you. Smart IoT, CCTV camera is a IoT device. Almost all CCTVs now enabled that is called power in Ethernet, and they are being connected just like a telephone and a mobile phone, and everywhere from you can access the images from any remote locations through internet. Therefore, it becomes on a internet of thing CCTV. Smart city deployment, I think this is an example that we can use CCTV because somebody is, I think, accident occur, or a fire incident occur, or a chain snatching occur, a murder occur, a gunfire occur, and my CCTV camera can able to detect and also provide an alert in seconds. That is actually the objective of a, I think, SOC efficiency, that is called SOC operations. Therefore, that is called Security Operations Center. We'll be discussing perhaps if there will be AI in threat intelligence, predictive defense technology, IBM Watson AI. Therefore, that is called proactive threat detection, early warning, malware, and that is one of the important research area where people are working on this. I mean to say, you see, earlier the signature mechanisms like that, we have a firewall, we have an antivirus that based on the signature. But here actually in the, I think, future, what type of attack occur based on some behavior, a proactive threat detection model, early warning on malware and insider risk, that is being often. We have many applications that is being there. We call next generation firewall, IBM, Cisco, and many other, I think, security companies. They provide some of the solutions of this, that is called threat intelligence and predictive defense. Particularly Palo Alto is one of a network security company that leads into this category. Palo Alto's next generation firewall is one of a important, I think, asset for security incident. Communication and content threat detections, I think AI in email security and phishing preventions. You see, the Google can now provide phishing, and it is being blocked Delhi using ML models. Airtel, even they are advertising that, okay, the Airtel payment can able to provide a, I think, phishing or a fraudster, I think, approach. In case if a fraudster calls. Similarly, how it has been often, it has been often by using the AI. Therefore, there is a first research, I think, scope that is being there. You can have a data, and you can apply a project, you can purchase some of the data, and you can do some of the research. And that is called Facebook NLP monitoring, real-time detection of harmful content, improved trend analysis. This is one of a important research area where actually you can similarly we can find out, because social media plays a very important, I think, aspects of national security. Because you see, even if 6-7 years back, there is actually stampede occur in the Bangalore, I think, railway station. The reason behind is because there was a, I think, propaganda occurred in social media that you see the people are from the some of the states of India that was being targeted by. Therefore, all of a sudden, I think thousands of I think passengers, they come to the Bangalore station and they go to I think their train. There is a stampede occur. Therefore, social media. Therefore, if we can detect some of the harmful content and improved things, that is also can be taken, and it is actually doing that. Similarly, AI for financial fraud detection, that is actually I have discussed. And okay, vulnerability and patch management, 90% drop in phishing incidents, that is actually US government agency and Tenable. AI for vulnerability, AI can be used very much defensively, where 90% drop in phishing incidents that is being occur. This is another area where AI for I think AI coding assistance, creation of malware, enhanced of phishing images, messages. Okay, we will be. I do not want to go on the things. Let us talk about SOC, where actually we are. I think this is one of a proposed solutions of our Delhi police operations. SOC generally, that is called a single platform to provide asset discovery, vulnerability assessment, behavior monitoring, intrusion detection, and security incident event management. That is one. You see, if you see there are 10,000 of internet connector users, and it is very difficult to see in the naked eye to find out what type of alert it is being there. Therefore, the AI can be used to alert, and automatically it will be provided solutions. That is the objective of a SOC. It monitor, analyze, correlate, and escalate intrusion events, develop appropriate responses, protect, detect, and respond, conduct incident management and forensic investigations. And you see, if you are actually a security person and you want to have a security company, then there is a very good scope that you can, you are good at AI handling. Therefore, you can provide a next generation SOC for the companies, for your organizations, or you can approach other organizations for a product. Cybersecurity, this is how a generally I mean to say a SOC being designed. Particularly if we talk about the cybersecurity, we have people, process, and technology. That, and this is the layers where actually we can do. Generally we talk about, and then every layer there is a concept of AI. That is the reason that AI in cybersecurity is one of the important applications where it can be exploited very easily. Therefore, we talk about now the basics, which actually I think my topic was the basics of AI cybersecurity. I discussed about why we need a cybersecurity, what is the applications of AI in offensive as well as defensive. Now, the cybersecurity basics, as you know, any cybersecurity solutions that provide a CI trend, that is called confidentiality, integrity, and availability. Confidentiality means my data should not be I mean to say it should not be, I think nobody can able to understand my data. It can be intercepted, but not can be interpreted. Therefore, we need a proper encryption mechanism to do. Therefore, cryptography plays an important role to provide confidentiality of the data. Therefore, now there is a research on post-quantum, because that is the quantum computer that is coming off. Therefore, whether the encryption mechanism that is being used in today's computer, whether it is valid for next generation computers, which a quantum computer comes. That is the reason post-quantum is one of another research in these areas. Integrity, the data which has been sent to the user, that must be remains intact. In between, if the data is been changed, then it should but be detected. Therefore, we have a cryptographic mechanism to provide integrity, what we call secured hash algorithms. Availability, the data should be available when it is on demand. Any cyber attack, for example, DDoS, generally that has been due to that occur to disrupt the data. So this is what actually discussed about the CIA trend, and we talk about threats, vulnerabilities, like likelihood, impact. You please go to the NIST. There will get, and I'm discussing about the trends of, because you see these slides I wanted to see. Sir was discussing about 2017. If you talk about 2019, 90s, discuss about virus breaking website fast worms. Then 2000, 2007, 2014. Because you see, when the year coming, there is actually what I mean to say, there is the induction of new technologies. As a result, the cyber threat increases. Up to 2017 onwards, that is called post ransom. 2014, particularly e-commerce, m-commerce come to the mobile commerce come to the, I think, market. So that is the reason there is escalation. 2017 to 14, mostly mobile phone comes to the 90s to 2000, the internet comes to the picture, and 2014 onwards the IoT comes to the picture. 2017 onwards, there is a corona comes to the picture, whereas corona, the internet users actually, I think there is a substantial increase of the internet users. Post corona, 2020, 21, 23, 22, 23, it is because the use of internet user has been exponentially being increased. That is the reason that the cyber threat increases. Okay, common source of cyber threats, nation states, terrorists. I'm not going to detail, already we discussed, because there are some other things that I wanted to discuss. That is actually the cyber threat taxonomy. I'm talking about the threats occur targeting the industry, mobile operating systems. That is a classification. So we have made this paper in 2018, and it was been published. That is one page, talk about actually what are the various cyber attacks that is being covering industrial, what we call SCADA, or and mobile operating system, web browser, and this is what happens, right? This is actually some of the, because the basics to be discussed, because I have already discussed the advanced version, therefore we do not need to, but somehow you see Stuxnet, if you go to the cyber threats that affecting industrial application, the Iranian nuclear power plant was being paralyzed by the US hackers. The objective was to sabotage. So this is what happens, the targeting the, what we call the industrial sectors, and targeting operating system, targeting web browser. What is the target area? Based on that, the taxonomy was actually made. So that is actually what we called discussed. Now, because the course actually they covered the artificial intelligence, the brief discussions about AI. Therefore, I'm talking about the brief discussions of AI. AI mostly is a branch of computer science that focus on designing, capable of performing tasks that typically require human intelligence. I'm discussing about how AI used as a deepfake in the latter, because most of them faculty members, and they must be teaching cyber, I think, artificial intelligence or machine learning in their domain areas. But these are actually the core areas of intelligence, include learning, reasoning, problem solving, perceptions, and natural language understanding. The goal of AI to build intelligent systems that can sense, analyze, learn, and act anonymously while improving their performance over time. These are actually the branches of AI: machine learning, deep learning, natural language processing, NLU also, natural language understanding, expert system, and computer vision, and more on. Therefore, machine learning, the key ideas to model to detect patterns, improve with experiences, make predictions or clarifications. Let us, I am not going to details about the AI part, as well as I do not want to discuss the ML part. Let us talk about the topic that which is more relevant, that is called deepfake, how this AI can be used to detect a deepfake scenario that I am giving an example. Applications of AI is using the deepfake. This is what I can say. The deepfake are AI generated synthetic media. That is, I'm talking about how it has been. Therefore, AI detection, deepfake detection is one of the issues in the national, I think, arena. Therefore, you can do a research and write a proposals for deepfake, either for video, image, audio, system, voice calls, and synthetic avatars. So this is actually one of a research area where Government of India is also accepting calls for proposals. Therefore, you are all advised to do. And I am actually, because there are, if you talk about video, image, audio, there are most, but I'm talking about deepfakes of the logo, which is one of my research area where my students are doing. This is actually common type of deepfakes, that fast face swapping, lip sync manipulation, identity reenactment, voice cloning, and full body motion synthesis. Why deepfake research needs attention? Rapid democratization of generative AI tools, minimal technical expertise, increasing realism, difficulty in detecting synthetic content, lack of legal and policy frameworks. Challenges actually somehow, because in an institute you may have certain challenges about the data, but however you can, I think that can be very much, because you see Indian data is not available in the Kaggle in open source, but however there are data available for doing research. Actually, this is one of actually a deepfake where I am working, that is called logo deepfake. Logo deepfake refers to AI generated or AI manipulated versions of brand logos created using deep learning and generative models. Because logo deepfake that leads to counterfeit product labeling, phishing websites, and scam publications. You see, if the logo is being, because the brand is being using a logo, therefore if I'm using I'm a local vendor, I'm using a top brand, by the logo itself, people are very much familiar with the logo. And that is actually one of I think the fraudsters, they are using deep fake logo to generate business. That is one of area where we are using, but there is actually very less data is available. And AI the future. I'm concluding now because time, there is 10 minutes, because up to 8. The future of proactive cybersecurity is AI, artificial intelligence, is increasingly employed in cybersecurity to automatically analyze massive data sets, identify patterns, and predict potential threats, transforming traditional security measures into proactive and adaptive systems. The key benefits includes AI enhances detection speeds, reduces false positives, and enables real-time response capabilities, leading to more robust and efficient cybersecurity defenses. And AI technology in use, machine learning algorithms for anomaly detections, AI-powered threat intelligence platforms that I have already discussed how AI can be used for threat intel. Leading organizations like IBM, Google, and Infosys, our Indian company, they are also using Infosys Hunter for its threat intelligence. Similarly, almost all security agencies, I think companies, they are having their own AI-enabled threat intelligence model, and it has a success stories. The deep learning and pattern recognition utilizing complex neural networks to analyze and learn from security data. These AI techniques identify unusual patterns that signify potential threats, substantially reducing response times. Predictive analytics, AI algorithms predict and preempt security threats by analyzing historical data and identifying potential future attacks, allowing organizations to fortify their defense productively. One of I think important, that is called predictive policing. What actually the safe city projects that is demanding. I mean to say, you see, I know that in Delhi, particularly in certain cities, when there is actually a conflict can come, or there is a, I think, threat to our infrastructures. Therefore, in that way, if my system can able to predict, then proactive solutions can be measured. The implementation challenge, the complexity of AI systems, the need for large data sets, and potential biases in AI algorithms pose significant challenges in their adoption and effectiveness of cybersecurity. That is actually the data set where I can do research. Therefore, you have to approach, suppose if you need to do something on healthcare, you have to approach the data to the, because BPDP Act that comes into the picture, where actually privacy is a fundamental right. Therefore, ethically, how the data can be used, that is a requirement. Issues such as privacy concern, the potential for misuse of AI technologies, and the need of transparent AI operations require careful consideration, regulations to ensure ethical deployment in cybersecurity. This is actually the future of proactive security. I'm sharing one of the, I think, the key points. AI is revolutionizing cybersecurity by enabling proactive. You see, I'm talking about cybersecurity. AI is a tool to cybersecurity. I'm not talking about AI is a tool for weaponizing cyber crimes. I'm talking about AI is a tool to proactive cybersecurity. That is, I'm talking about. Therefore, I'm advocating AI for the cybersecurity solution. As cyber threat evolve, ongoing innovations on AI technologies is crucial for staying ahead of potential security breaches, emphasizing the need of advancements in AI applications with cybersecurity. There is another 10 minutes. I'm talking about one of my research where actually you can use this is one. You see, this is one of a paper where actually malware analysis and detection technique using adversarial learning and deep learning. There's Journal of Information Security and application that was published in, I think, recently. Therefore, you see, I think there is a novel, I think, framework that has been used. Anybody can use our data, as well as you can enhance this paper. There are some drawback. You go to the last slide of the, I think, research where it has been given what actually it does not cover. Therefore, you can also work on that. And we are free, I think, we are ready to provide you the data set that we are using, that we have used. And I think this is actually, if you go to I meant to say, go to the problem statement, the solutions are promising. Therefore, I think the accuracy is almost based on that thing. Therefore, okay, because there are 5 minutes left, I do not want to go. Thanks. Thank you so much for, I think, patiently hearing the lecture. But I hope that I can able to give you some of the insights to all of you. Thank you. Because any questions, we can have another 10 minutes for a question.
Thank you so much, sir, for sharing your insights. That's true.
Actually, madam, you see, because you see, the topic is so debatable. You see, what you have given, introductions to AI, ML, and cybersecurity basics. But you
Yes,
see,
sir.
because there are 3 different aspects, intersection
Yes,
of all this. Therefore, somehow I have managed, but I do not know how far I give an impact to the participants. Anyhow, a quick questions from the audience. Thank you, ma'am. Please.
yes, sir. Sure, sir. I request the participants to please raise your hands if you have any query, and we'll give you the audio permissions.
Okay, before that, let me मैं और कुछ बताता हूँ, because I am a faculty, because all are faculty members. Particularly, my research area is on cryptography. You see,
Yes,
I worked in the cyber security issues in Delhi police because I got an opportunity there. I worked, and you see, I teach cyber security, but mostly cryptography is my area. Even if beyond that, any of the faculty members, they want to have certain questions on crypto also, I am happy to give solutions for them, and I can provide you the tools and terminologies how it has been often. And thank you. Besides the cyber security, because AI, ML, though I am doing research, but I'm happy to help in the cryptographic areas, as well as the cyber forensics areas, where actually there is a, I think, demand from forensics people. Thank you. Any questions, please? Thank you.
Thank you so much, sir. It's true that we always need a mentor who can actually guide us in cryptography and all. So you will be a great mentor for us. And really thank you for even suggesting us to extend your paper that is on malware analysis. So we are really thankful for that as well. And I am giving the mic permission to Mr. Nishant right now. So please open your mic and
Okay,
ask
ma'am.
your
Thank you
query.
very much. Good evening, sir. Myself, Nishan Joshi. And sir, I'm already, sir, PhD scholar in forensic for reconstructions of evidence and also using in AI. So, sir, can you guide me, sir, which AI or which way I have to going using for the forensic for regarding or making a system for the automated generated for the reconstruct of evidence and the data? Hello.
You are doing in particularly elective curve cryptography. It is elective, it is elliptic curve. Anyhow, because you see applications of AI in forensics, no doubt it is promising, because I do not have enough idea on forensics, how AI is being used in forensics, particularly deepfake, and one of a area where we can use AI in deepfake identification and deepfake forensics. And I mean to say, particularly here in India, but when we talk about the forensics, mostly the challenges in forensics occur by the law enforcement agencies. I can chalk it out. You see, if you talk about here, particularly the forensics from law enforcement angles, we talk about disk, mobile, and internet forensics. Beyond that, WhatsApp forensics and your crypto forensics, blockchain forensics, cloud forensics is a challenge. Therefore, I think I am not expert in particularly how AI can be used in cyber forensics. You can actually go to the NFSU, National Forensics, I think, University, and Professor Parag. You can he is actually the cluster head of cyber forensics group of ISCA. There you can get a better idea from him. I will connect you. You can have my email ID. You please give your email ID, so that in which domain and from which institute you are actually doing your PhD.
Sir, I'm doing, sir, I'm from the Gujarat, and Marwadi University, I'm doing a PhD.
Okay. Because you see, in Gandhinagar NFSU, you can search
Yes.
Professor Parag, actually, Professor Parag NFSU. You
Okay,
Google
sir.
it, and he is actually, they are actually, people are actually working in cyber forensics, particularly how AI can be enabled in cyber forensics. In case you can directly, you have my email ID, you can check your problem. I will give exactly, I'm not able to understand what actually your problem is. Even if
Sir,
he can betterly guide you actually what are the areas of AI where actually forensics can be used. But no doubt forensics can be used for, you see, for encrypted purpose and code malware, no doubt for malware detection, deepfake detection, and investigations. AI is a tool, but particularly the forensics of disk forensics and mobile forensics, internet forensics, and other forensics, where law enforcement agencies, and even if CCTV camera forensics and drone forensics, where actually these areas where law enforcement agencies are struggling. In these areas, actually, how AI, I don't have an answer right now. You may approach to the NFSU professors and others in that. Thank you.
okay, sir. Thank you very much for the guidance, me.
Thank you, sir. Now I am allowing Dr. Lakshmi for her query. Dr. Lakshmi, please switch on your mic and ask your query.
Otherwise, ma'am, you can share my email ID to them, and in case if any queries, I'm happy to provide an email answer to them. In case if I find the answer, that is fine. If not, then I will definitely have connect with them right people in India who can, particularly in forensics and other areas.
Sure, sir. We can do that as well. We have 3 more queries if you allow me to.
Take me a minute. Let me check the queries. Elliptical curve cryptography. Yeah. Elliptical curve cryptography, somebody has noted. You see, if you talk about it, is a public key crypto, and mostly sometimes RSA is a heavyweight cryptography. Elliptic curve cryptography is a lightweight cryptography, and much more research has been done, because whenever we talk about to apply a digital signature mechanism or authentication mechanism, then generally we use elliptic curve crypto system because of its lighter nature. And the question is in which areas we can use elliptic curve cryptography. They are particularly in IoT domain, where there is a less computation. I'll discuss about the Cloudflare. Okay, I think the elliptic curve crypto, particularly IoT authentic, because you see public key crypto systems are used for authentication purpose. Authentication का मतलब ये होता है, I mean to say mostly the two type of authentication. One is called certificate based authentication, certificate less authentication. Certificate based means digital signatures. Digital signature is nothing but a public key crypto system mechanism. RSA based digital signature is heavyweight, which is not advisable for a lightweight environment. Lightweight environment means particularly the IoT devices, they need less resource computations. In these areas particularly, elliptic curve cryptography is very much used, and it is a, I think, well known. I think if you find, I mean, there are thousands of research papers that is being obtained. Sometimes signature and encryption that is being grouped together, where signature is being elliptic curve, as well as the hybrid crypto systems where the key is being used for encryption and the mean to say the key is being itself secured through elliptic curve crypto. So you can go to the basics. Okay, modern cryptography, particularly, you see, what does it mean by modern cryptography? Means recently we have a post-quantum crypto. A post-quantum crypto means you see how we can defend the crypto system using, if there will be quantum. So I think quantum computer comes. The only solution is just increasing the key size. So if there will be quantum computer, then it takes some time to decrypt. Therefore, earlier it was 256, the key size will be 1024. Then also this is how we can. Therefore, the modern crypto, today's recent post-quantum crypto that is being achieved using the classical crypto system that is being using larger key size to prevent a post. There are so many post-quantum crypto algorithms that is being there. Okay, you see, let me check some of the questions.
Okay, sir.
Just a minute, ma'am. Modern cryptography, intrusion detection versus B2B communications. Working on user behavior pattern security application. For user behavioral data set, how to get it? You please search the Canadian Center of Cybersecurity. Perhaps you may get. Otherwise, I will give you in case if there is something. My email ID is there. I think madam will share you my email ID. You can write a email to me to provide a. And you see intrusion detection systems. I think how to detect and mitigate passive attacks like eavesdropping. Only that is possible. Passive attacks cannot be. That is the problem with eavesdropping. Passive attacks, somebody is actually eavesdropping passive attacks. Just see. Only encryption is a method. Otherwise, vulnerability management is one of the another method. How somebody can infiltrate and see the things. Okay, thank you, ma'am. I think you please share my email ID. Perhaps it is because the questions are very much similar. I will take some of the questions. Definitely, I will answer later on.
Sure, sir.
Thank you.
Sure, sir. I'll
Thank you.
share your email.
Yeah, definitely.
Sure, sir. I'll share your email ID with the participants. And thank you so much, sir. With this, we are coming to an end of our first session that gives us the understanding of cyber threats landscape, ML and DL use cases that included LLMs and Gen AI. And we are confident that the insights which are shared by our resource person has set the right context for the advanced topics to be discussed in the upcoming sessions of the FDP. And we are really thankful to our resource person for giving us his time and for sharing his expertise to the participants. Thank you so much, sir.
Thank
And
you.
with this, we are taking a 5 to 10 minutes break for starting the next session. So I request all the participants to stay tuned with us. Within 5 to 10 minutes, we'll start the next session. And thank you to our first session resource person, Mr. Professor Dr. A.K. Mahapatra. Thank you so much, sir. Welcome back, everyone, to this 1 week Atal Faculty Development Program on emerging trends in AI powered cybersecurity. So, we are now at the second session, and I take it as immense pleasure to warmly welcome Dr. Indranath Chatterjee as the speaker of the second session. We are honored to have him on the board, and we look forward to learning from his rich academic and research experience. Dr. Indranath Chatterjee has done his PhD from FHEA UK, is currently an associate professor in the Department of Computer and Mathematics at Manchester Metropolitan University, United Kingdom. He earned his PhD in computer science from the University of Delhi with research focusing on AI-based automated diagnosis of neurological disorders. Dr. Chatterjee has extensive academic and research experience across the UK, South Korea, India, and Europe, and has been actively involved in several internationally funded research and industry consultancy projects. He has made significant research contributions in the area of artificial intelligence, machine learning, computer vision, time series analysis, and intelligent decision making systems with applications relevant to modern crypto cybersecurity. He has an impressive record of publications in high impact SCI and Scopus Index journals, reputed international conferences, as well as books, book chapters, and patents published with leading global publishers such as Springer, Elsewhere, Taylor and Francis, Wiley, and IEEE. He also serves on the editorial boards of international journals and regularly reviews research for top tier publications. Dr. Chatterjee is a fellow of Higher Education Academy and a recipient of several prestigious recognitions, including the Exceptional Talent Endorsement by the Royal Society UK and the New Starter Award 2025 at Manchester Metropolitan University. He is also a frequent keynote and invited speaker at international conferences, FDPs, and academic forums. So, we are delighted to have you with us as a speaker for this second session. And on behalf of the BCIIT, the organizing team, and all the participants, we extend a warm welcome to you and request you to please begin your session.
So much, Dr. Soba. It was very delightful for me to join this program and disseminate my research to you and all the participants. So it's quite a big honor. Thanks for inviting me. So unfortunately, I cannot turn on the camera. Can you please check on this? And also cannot share the screen.
Sure, sir. Sir, you are a presenter, so you can easily do that. Are you unable to switch on your camera and share the screen?
No, whenever I switch on the camera, it turns off automatically.
Okay, let me check, sir.
Yeah, maybe the permission issue.
Maybe that. Amit sir, could you please make him an attendee and again give him as a presenter permission?
Yeah, okay, ma'am.
Okay, let me try. Sir. Okay, sir.
Sure, no problem.
I think it worked now, right, sir?
Yeah, I can now share the screen maybe.
Okay, okay. Thank you so much.
Okay, so hello everyone. So as you have already got my introduction, so today I'm going to give a presentation on a topic like the application of AI in cybersecurity. So basically, when I talk about this AI and cybersecurity to you, I want to introduce myself to you in a different way, like already Dr. Zova has introduced me, but still just for the instance that we may require you to understand like why I'm talking this part of the cybersecurity, just to introduce you. So I'm currently working as an associate professor at Manchester Metropolitan University in the UK. And apart from that, I'm currently affiliated to some other universities as well. Like for example, I'm working as an AI research consultant at Korea Aerospace University in Seoul, South Korea. I'm also working as a collaborating faculty as International Neuroscience Research Center in Georgia. I'm actively working as an adjunct professor at Oxford University, Modi University, and Chitkara University in India. And I'm also working as a general director of the Korea Multimedia Society in South Korea. So it is the largest computer science society. I mean, it's a government body. It's a government uh, computer science society of South Korea. It's the oldest and the largest one. So we used to disseminate different knowledge of the computer vision, image processing, and these things across the globe. So while I'm going to give you a presentation on cybersecurity, but honestly, I'm not an expert in cybersecurity, but I'm an AI expert. But I do research in the other fields of AI. My primary research focused on computational neuroscience, medical imaging, computer vision, NLP, and I also work in the interdisciplinary areas like blockchain and IoT. Security and UAV, the unarmed aerial vehicles. So that's a part of my contribution to the cybersecurity part. So recently, I have been accredited by a lifetime fellow of Higher Education Academy from the UK and giving me the title of FHEA. And I'm also being accredited with an exceptional talent from the Royal Society UK. So I do research. I have a lab here as a strategist neuroimaging and AI lab. So we have a group of PhD students, postdoc students, and different research assistants, master students, MPhil students. So we are all working together in our lab, and we work for different areas of computational science, different areas of NLP, computer vision, and most prominently the medical imaging. So this is my link to connect. If you want to connect me on the LinkedIn, if you want to read my research and something, just Google my name, Dr. Indranath Chatterjee. You will find everything about me. And so this is all about me. So now I want to start my presentation today because it's important to know what is my background so that you can connect and you can ask me the question if you have for the applications of AI. So today's lecture I have divided into four parts. So the entire lecture will be part into vision, NLP, health, and defense. So when I'm talking about the different parts, the vision deals with the seeing the entire cybersecurity aspect from the computer vision perspective. So when we can take the data or like any kind of code or any kind of virus, any kind of ransomware as a part of image or as in an image form, so we can easily apply the computer vision knowledge to treat those. Then the part two will come to the NLP, that is natural language processing, and I'll show you my research on the application of cybersecurity for the natural language processing perspective. Then we'll talk about the health. Here we'll not talk about the healthcare, but we'll talk about the health of the security concern that we are dealing with the cybersecurity or any kind of security in entire World Wide Web. So we'll talk about the anomaly detection and IoT and UAVs. So I'll talk about my contributions there as well. And then we talk about the part four, which is the defense. So in the defense part, we will go to some upside down. So we'll not talk about any more security here. We'll talk about the breach of the security and we'll try to do it that. And after I explain you all the four parts, I will, as this is a workshop and I know a lot of people are here more interested about my lecture, but like much more interested about the actual application. So I'll show you a code and that code will run on some toy examples to show you how vision and OP health and defense actually works with the AI. So I'll show you the live demonstration of that. So let's first talk about the vision and why I'm the person to talk about the cybersecurity here. So as you know that I'm a computational neuroscientist, I work on the AI expert. So how this relate to the brain and how I can work on cybersecurity as well as neuroscience. So basically, as I told you that I work in the field of AI. And when we talk about the AI, it's about like digging the brain, digging any kind of data as a data scientist. So I work here as a data scientist and In the neuroscience part, we talk about the brain. In the cybersecurity part, we talk about the noisy network data. So why network data are noisy? Because in the entire World Wide Web, so we have like trillions of data generating every week, every year, and so on. So we do have entire data in a unstructured form. So when we have entire data in unstructured form, it's quite difficult to dig and quite difficult to unhide those patterns that are hidden inside the data. So inside the data, sometimes those are benign, sometimes those are malignant. So when we talk about my research in the brain science, we look about anomalies. Anomalies can be like tumor. If we talk about the structural MRI, anomalies can be dysfunctionals in terms of any kind of brain regions. Well, we talk about the fMRI. But in cybersecurity, we look for anomalies. Like the basic thing is the intrusion. We all know about this, like IDS, intrusion detection systems are quite popular these days. So when we look for these anomalies or intrusions in the noisy network traffic, so the entire math is all same. So how we develop the algorithm, it can be applicable to the other domain also. So only the data source changes. So we will now talk about and show how we can actually leverage all those things together in a cybersecurity perspective. So first we talk about the problem space. Why this is a big problem? The problem is that in a huge data, I just told you, like we have thousands and thousands of data being generated every seconds. Even in any network traffic, we don't use any kind of traditional TCP/IP protocol to gather those data. So we have like huge AI-based platforms right now. We are trying to find the real-time intrusions in the way. So we'll talk about those. So every single day it's a research proof every single day around 450,000 new malware variants are detected. So can you imagine the number of the malignant data are being forming? For example, when we talk about the noisy data, or when we talk about the malignant intrusion, when we talk about the virus in a whole term, we can imagine like even we can get the real data, still we cannot imagine like how big their chunks are, and they are generating every single day. And how it generates, the hackers, the spammer developers are just changing a single bit in the code, and the codes are like thousands and thousands lines of like the programmings. And when they change a single bit inside those, we cannot detect that. And the traditional antivirus algorithms, firewalls, or any kind of malware detection algorithms fail to do so, because if the variant changes every single day or every single week, so how can we update every single antivirus, every single firewalls in a in, in a real time? So that's impossible. So estimated cost of cybercrime in 2025, we have our estimation of 10.5 trillion US dollar. That's a huge money. That's a huge money we work for. Like in the UK also, we work for like every day. There are some sort of breaches in the railway networks. There are some sort of breaches in the UK Parliament data. There are some sort of breaches in different aspects of the university systems. And we in the UK also, we are dealing with these things. So it's a big thing. And it's a real proof that when we have a new data breach, sometimes it may not detect it instantly so that we can stop. Sometimes it takes days, years to detect that there was a data breach long back. So that's the horrible side. So why the traditional defense system fails? Why do we need to learn? Because like in the 5 years back, there was no application of AI in the cybersecurity. Then why the people in the cybersecurity right now, while the people in the network security right now are talking about AI, why do they need to learn about AI? Because the traditional defense system is completely based on signature based detection. So let me give you an example to explain. So the traditional defense system is like a doctor who have learned and memorizes the textbooks, every single beat, every single line in the textbook. Now, when it try to diagnose a disease, can the doctor can diagnose the disease easily, because if some sort of like high temperature in the body, lower blood pressure, or some kind of like symptoms in the cardiovascular, then we can detect like this can be the disease. But what will happen when a new disease will come? That's the reason why the symptoms of the coronavirus like was unable to being diagnosed by the doctors initially for a few weeks, and they didn't know. They thought it like an pneumonia, it can be like a tuberculosis, what kind of, which can be like a flu, but it was a completely new disease, and it took few days, few weeks to diagnose. So traditional defense systems is like a traditional sick doctors. But when we talk about the new cybersecurity system, it's like in AI. So AI is a doctor who understands the symptoms, learns the symptoms every single time, and try to diagnose and fit it with the instant anomalies that it learns from. So how it works? So when we talk about the signature-based detection, it's what works like a wanted poster. So if the virus code matches the database exactly, for example, we have a set of viruses, and we have fitted those viruses in the malware or in the antivirus system or in the firewall. So they have the knowledge of that entire piece of codes that looks like virus. But when a single change in the virus database makes changes, so what will happen? It will definitely get deflected, and that's a failure. So when we have a failure, we cannot detect that virus or spamware anyway. So that's we call it as a polymorphic malware changes. So it's the if the code slightly changes. And it can still work for the traditional viruses or traditional spamware. But what about the zero-day attacks? You must know about the zero-day attacks. Zero-day attacks are the attacks where the virus has been formed and it attacks for the first time. And 100% of all the firewalls fails for that. And that's the definitive way of saying that how the data breach happens. So there comes the advantages of AI. How AI can actually help in this scenario. So AI can handle various things other than only the malware detection. It can handle the volume, it can handle the velocity, it can handle the variety, it can handle the learning power. So when we talk about the volume, I told you like we have terabytes of data being generated every single seconds. And all these data generation creates another log. And the logs are much more bigger in size than the actual data. So when we analyze these terabytes of logs of data in seconds, that would be like magical for any kind of malware detection algorithm, right? So we need AI. What when we talk about the velocity, we talk about like different kinds of responses we used to get while we are getting to the attack. So for example, we have to react instantaneously to the different malware or the spamware we're getting. We are talking about the different variety of malware, and these varieties may not have a certain part of change. This variety can have a slight changes, because when we talk about this spamware, when we talk about this malware, a single bit of change is completely indiscernible. So I'll show you a code today and demonstrate the code to you that how we can change those single noise to make the images like look same, and still it carries any kind of malware codes. And learning, that's the main part of AI. We all know that AI is a big uh, thing which can help us to learn. For example, in machine learning, deep learning, reinforcement learning, federated learning, we can have different kinds of learning protocols. So AI is important. Now let us talk about the computer vision, how we can leverage computer vision in cybersecurity. Okay, so let's talk about the any code. I hope like most of you or maybe some of you have already seen or decrypt any malware so far. If you have worked in the cybersecurity, if you have worked in computer science security domain, you must have seen even a small virus, or if you have seen certain part of spamware. So if you have ever decrypt that spamware or malware, it consists of a sequence of bytes. So, and the sequence of bytes is a sometimes it's in a hexadecimal code. And we can convert these hexadecimal codes into a grayscale values. And we all know that grayscale values ranges from 0 to 255. So if we change this hexadecimal codes and convert them into grayscale values, What is the result? The result is simply a fantastic image. But why I'm saying this fantastic? Because images you can see here are so noisy. But this is fantastic to a computer vision scientist because computer vision scientist requires challenge and we need that. If we have a challenging pictures, we can have more things to decrypt from. But otherwise, it looks like a like CRT TV noise, right? When there was no signal from the cable, and we used to see this like hazy noises. It's and each one of them is quoted here are actual formation of the viruses. It can be a virus one, it can be virus two, it can be virus three. I'm talking viruses in terms of everything like spamware, Trojan, everything. Okay, so each of these executable file that can work and that can I can say that can destroy your computer, that can crash your computer. It's not just a code, it actually a unique representation of some visual fingerprint. So when we have fingerprinting techniques like we already use in steganography and all these things, so we can use this visual fingerprinting techniques in this spammer detection too. And in a visually, in a normal human sight, this kind of noisy data looks impossible to detect any kind of patterns. But when we apply the computer vision, we can slice it down into single instances. We can slice it down into different windows, and we can see the patterns and the change in the patterns. And those changes in the patterns are exactly what we need. We can talk about those patterns and the changes in the patterns and see what coming next. And if it doesn't follow those things, then that must be an anomaly. So that's a very quick and very simple trick to do that. But although this trick cannot work for a real spamware, because real spammers are really intelligent and really smart, they are developing new spams because they already know this. They might attending any FDP on the cybersecurity and learning what are the ways to bypass those. So so that's why they are also learning. We are also learning to fight with them. So that's a bit fight between us. So but still we have to be positive. We have to think like how we can decrypt those things. So there is a big work by the Natraj et al. In 2021, and I worked on this paper. So when we seen this paper, the team has uh, developed a methods and proved that different malware families, for example, worms, trojans, ransomwares, have different visual textures, different patterns of their representations. So if we can detect this kind of patterns, if we can understand this kind of patterns, so why this pattern is important? Now you can ask me the question like, okay, if we have 450,000 new kinds of ransomware, new kind of spamware developing every single day, then how can this malware or the images or these patterns exist? Because even if we train those machine learning model or the AI model with this kind of few or or maybe hundreds of new kinds of malwares and understanding their patterns, then how the new pattern that has been generated the very next day, how we can detect that? And that's a huge challenge because we cannot update our machine learning system every single day. We have to wait for a few gap, a few window because we cannot train with a single data again. We need to have a chunk of data again to retrain the model. So so what we can do with that, that's a big challenge because we cannot wait that once a model is being trained and we can apply that on a uh, network, and the network can detect any kind of ransomware, any kind of worms or any kind of viruses in the security zone, and it will protect and it can work for next day, and the new kind of malware develops and it can bypass. So what we can do, so if we can find this kind of patterns or any kind of patterns basically inside this uh, each of these worms or each of these trojans, we can generate our understanding. The machine learning model or the AI model can actually understand, actually learns the pattern. So we call it as a pattern recognition. So it can recognize those patterns and see the changes. If a fake green virus, it's the number E, have a certain pattern, And if these patterns look similar to the like benign signal, but it has some kind of uh, noisy data which seems it to be a malignant, then we can identify those things. And once we can identify those single pattern changes, we can easily train ourselves with those changes and look for similar kind of patterns in the next streams of data. So that's why instead of updating us every single day with new kind of spamware, we can actually work on the same group of spamwares, but understanding the patterns and disseminate the benign and malignant signals. So when we talk about these distinct visual textures, so we can talk about three different things. One is a benign software, which you already know, and Trojan and worm. So in information security, we have a term called entropy. So entropy means like the noise is the amount of informations that we have. And when we have a high entropy, it generally looks very much noisy and very fascinating to the computer vision scientists. So we can identify that something fishy is there, something wrong is there in the data before if it has high entropy. But sometimes it may not happen. Sometimes high entropy can be a like benign data as well. But still, when we have a high entropy, we get a notification that sometimes something is wrong. So if it looks like a static noise, then it's fine. If it looks like a dynamic noise, then we have to look for that. And same with the worm, because worms has a tendency of often having some repetitive sections, like creating stripes in the images. So if we can find this kind of textures in any kind of data, then we can identify that yes, that can be a worm, but then we have to decrypt more when we have to understand the pattern more to find like what kind of worm is it. Okay, so that's the distinct visual textures we can find. So how to find those things using the computer vision? So many of you can know can understand the structure of a CNN, or most of you have heard the term CNN. CNN stands for convolution neural network. It is a basic structure. So we don't use CNN as in today's world, because CNN is a quite old topic now. We use different forms of CNN now, but CNN is a basic structures what we use. Why do we need CNN? Because CNN derives from the neural network. And neural network is a thing that is capable of working on large amount of data. And when we have large amount of data with large amount of features, for example, here, when we talk about the noisy data in the malware or the trojans, we require this specialized, strong algorithm that can deal with this data set. So convolution neural network is a specialized neural network that can work on image data only. So how convolution works? So convolution likes it's like a window, sliding window protocol. So when we have a small window and an entire image, we used to stripe them, and we used to go from one side to another side to extract the information, and then we create our own way of extraction that we call as a feature extraction. And how this feature works? These features are actually detecting the different patterns. Now, as I told you, like when we talk about the malware, when we talk about the Trojan, each of them have different patterns or trains of patterns. So when we can detect all those patterns, for example, if I talk about the image like a smiley, and smiley in a grayscale, like black and white only. So it's a circle with two eyes and a smiling face, nothing else. So when the convolution layer, when the kernel moves from left to right in a proper slide, so it will collect the information, like if the image or the pixel has any kind of higher values, or the pixel has any kind of lower values, it will try to gather the pixels, and it will try to capture each of the pattern, each of the trends. Now when this kernel actually moves from one place to another, it captures the patterns present in the Trojan, captured the patterns present in the malwares, and it try to detect the code blocks. And this is where we are increasing the dimensions. That means if we have one data like this, if we have a one data like this, and if we try to move our patterns from this side to this side, we are extracting hundreds of informations in terms of patterns in our next layer, which is called feature extraction layer. So one image turns into hundreds of tiny images. And each of these tiny images actually contains a fixed number of patterns. That pattern can be shapes, that pattern can be edges. Now it's our duty. We should understand like what kind of edges do we need to be marked as ransomware, or what kind of edges should be marked as safe. Then we have a pooling layer here. So pooling layer works like a dimension reduction. It will try to pool the multi-dimensional or high dimensional data into low dimensions, and then definitively it will convert all the data into the fully connected network. So fully connected network is this part is a simple multi-layer perceptron or MLP, or a simple neural network, you can say. So this is a convolution part, and this is a neural network part, and entire thing is a convolution neural network. And inside the each of these nodes, in the connections with the hidden layer, input layer, and hidden layer 1, hidden layer 2, and blah blah, then finally in the output layer it try to classify that this image, what is the image? Image is a pattern formed or imaged form of the ransomware. It is a ransomware or safe. It is a virus or is it a safe. So that's how we work in the computer vision. But sometimes, as I told you, like we means the hacker or the people like of the people who are working on the computer cybersecurity thing. So we generate different kinds of malwares. And these malwares are generated randomly with a single bit of code changes every single day. Now, how can we update these things? And if we have a small set of data, for example, if you are able to collect like 200 or maybe 2000 types of viruses. Now, if you want to train that on the computer vision model, if you want to train that on a machine learning model, so how those malware data is actually helpful. So when we have a small data set, the machine learning model learns less. That means we have less number of trains or the pattern being saved in our database. And what will happen? We may not have a certain number of features which we are leaving behind. So what we can do? We can do or we can leverage the transfer learning here. So how to use the transfer learning? We can use the pre-trained model that has been already trained. For example, if we talk about the ImageNet, ImageNet is a large pre-trained model which has been already trained on cats and dogs images. So now you can ask the question like why we can use a pre-trained model that has been trained on cats and dogs images and use that on malware and spam. So the the intuition behind it is that we need a model that can discern the particles, that can discern the different images. Sorry. So if we have a pre-trained model that is a ImageNet and we try to train it again with maybe 2000 data sets that we have of the training, we can use the knowledge that has been already stored in the pre-trained models like edges and textures. Now, when we convert the image of a dog, it does not store the image of a dog as in a different part of the dog. So when we have a sliding window, it does not capture the like left ear, right ear, mustache, or nose, or eyes. It does not store like that. It extract the patterns, it extract the edges, it extract the shapes, it extract the textures, it extract the colors from those small part of a cat and store it as it is. So it's a very hazy. So if you break the convolution layer and if you can display the each of these small images in the convolution layer, you cannot like identify what is the actual input image. So what are these? These are actually patterns or trends. Even if we have these noisy images, even if we have these noisy images as an input, and if we have the noisy images of a cat, or maybe a fine, beautiful image of a cat, in the convolution layer, it looks the same. So that means we can use these transfer learning ways also in the terms of using a pre-trained model. So we have tried it in our lab also. We have seen like we are getting almost 98% plus accuracy with very minimal training data, which is a big challenge in most of the AI-based cybersecurity papers these days. You can Google it. You can see like how the AI-based cybersecurity papers are actually collecting data. They are working on synthetic data generations, but synthetic data generations often fails because that is on our based intuition. So if we use a synthetic data, it can form a different combinations of the actual data, but it loses the actual harmful thing, because when a spamware when a when a spammer or a hacker try to change a single bit in the data, it does not generate randomly any single bit. It changes mindfully and curatively a particular bit, which actually can cause the harm. So that means synthetic data is actually useless to use on a training the malware detection algorithm. So instead of that, why not you try for the transfer learning? So there is a very famous virus called WannaCry. So WannaCry is a very famous ransomware which have a very distinct visual patterns, and those visual patterns like seems to be a signature of that WannaCry. And this WannaCry has already been like caught. So we can this AI algorithm can spot this in milliseconds, but traditional algorithms can fail that because any ransomware creates a high entropy. And when it creates high entropy, that means high randomness inside the code. The code means the actual code of the virus. It changes the characteristics of the virus. It changes the visual signature of the virus, but the harmfulness or the bad side or the dark side of the virus still exist or even increase more. So even if the visual plot, even they look same, but their intensity of the harm can increase. So that's why high entropy sometimes looks like intense static noise. So in AI detection algorithms, we usually try to detect these noise textures because we are not now in a 2000 year where we want to detect the noise. We cannot only apply the outlier detection or anomaly detection algorithm anymore. We cannot just rely on detecting the noise because noise is fine, but we need to detect the noise texture. That's what we need to detect, like why the entropy is high and why this high entropy has some visual signatures. So what happened when these things happen? So maybe hackers and the spammers already know about this, that we can detect the noise signature as well. Instead of like not only about identifying the noise, we can now identify the noise signature. So hackers have done a different way. They have tried to pack the entire virus in some different package. For example, packing the entire thing in a blue packet instead of a red packet, and now it looks the same. It looks like the same gift pack but in a different color. Now, what will happen when this entire virus are compressed down into a single pack, and from the and how it still bypasses the antivirus scanners? The traditional antivirus scanners try to see the shape of the package or the style of the package. Even if it is a package, it try to read, but it cannot break into the packet. It shows like it can be a small packet and there is no suspicious textures. So that means we can bypass it. But what AI will do? AI will not only see the packet, shape, size, textures, it try to find the actual shape of the key or the keyhole, we can say. So, and if there is any change in the keyhole, that means that what we use as a public key and the private key, if we try to find the shape and texture change in the keyhole, that means the entire package is not a generic package but a cosmetically like induced virus, a compressed form of virus into the package, and AI can find that. So then the AI flag that particular file entirely and then dig into it, decrypt it, and find the uh, virus inside the mask. So instead of finding the virus, even if it is in a locked package, instead of finding the virus, AI can finding the mask also if there is some kind of locked and like strongly encrypted masked virus. That's a power of AI, and you can read some papers on it available on the Google Scholars, like how the AI can actually unmask the virus which are being strongly encrypted. So there are various kinds of grayscale images available of the malware families, and you can find them on the GitHub, you can find them on the Kaggle, and I would, if you are a professor, if you are a teacher, so please try to use those things for your students' projects and try to find and help them to understand how this computer vision techniques can work on these malware families. So if you go to the like MaliMG dataset, you can like more than 10,000 grayscale images of the malware families are there. It's very excellent for the students project to understand how it works. And once they develop the model, you can apply that on a new set of datasets. So that was all part for the computer vision. That is the end of part one, how we can induce computer vision in the cybersecurity. Now comes the next part, the part two, why NLP is important in the cybersecurity. Because when we talk about the NLP, because we talk about the linguistic, we talk about the language, we talk about like how we communicate with a computer in terms of writing, in terms of speaking, like speech or text. But how is it helpful in cybersecurity? Because always all the spammer or the hacker may not attack with the code. They can attack with the data, I mean text data. So 90% of the text data hackers uses an email. And you can see this email is a very common email, right? Like there is an urgent symbol in the subject line, and you can see like why it's written urgent. You can see like your account has been compromised. Click here to reset password. And I'm damn sure like many of you usually get this email in your main inbox folder instead of spam because your Google or Yahoo or whatever the server you are using failed to act on this, fail to find that this email is a spam. How to do that? That's where we need to apply the concept of NLP. So NLP, we are not talking about the LLM, we are talking about the traditional NLP, like how natural language can be processed to find these bridges inside it. So this, in terms of a data scientist, it's a very simple text classification problem, but it is very, very helpful for a cybersecurity person because to them, it's a lifesaver. It can be a spam hunt problem. It can be like finding a benign malignant problem, but it can be very helpful. So how we look for the NLP inside this data set. So when we talk about the sentiment analysis is a part of a NLP algorithm where we not only try to find like, is it a negative word or a positive word? We want to try to find the sentiments, the deep sentiments behind it, or the intent of the email. Is the email is actually a positive email? Is the email is actually negative email? Or is it a threat or is it kind of urgency? So what's that? So hypothesis says that if an email, I mean, here I'm talking about all kind of spam email. So when we talk about the hypothesis says that if an email has an high urgencies, if it has a financial request, then 99% of the time it's a phishing email. And how to prove that? If our NLP model for any kind of phishing algorithms can find those positive and negative words. So we use this kind of models for our different kinds of application in our lab for kinds of movie reviews or kind of news reviews, but we can use those models in the cybersecurity also. So we have that model ready in our lab. So if you need help, I can help you in the detection of the malicious intent. So we use this model, we developed this NLP model, which can find three different things: urgency, threat, and financial concerns. So if we have a keywords like immediate, suspend, now, if we have a words like log, delete, report, if we have a word like bank, verify, and invoice, we definitely know it matches our hypothesis, then that means the sentiment of the entire email is not a benign one. It's something fishy there. So another research that we do in our lab, so it's a sarcasm analysis. So sarcasm analysis is a different part of sentiment analysis. It's not only classify a positive sentiment or a negative sentiments, but beyond that, it try to find the exact intent or the sarcasm uh, uh, hidden behind these sentiments. So most of the time the hackers these days are using sarcasm in the social media manipulations. Sometimes in the Facebook post you can see a very uh, nicely written post about a science article about a daily life, and it's written everything. You click a link and the link looks very fine. It can be a link to a website of their own, but when you have those feelings of no, this writing is good, this blog is good, this post is good, and they do this SMM, that is social media manipulation. We sometimes call it trolling, but that's the negative word, but we call it as a spear phishing. So spear phishing is done in emails, and SMM, that is the social media manipulation, works in social media posts like Facebook posts or Twitter posts, where it is the sarcasm is hidden behind it. So it tried to lower the targets using some casual jokes, but those are threatening. Let's see some examples. The first example is like, if you have seen this kind of email, for example, your account is locked, click here immediately to restore access or you will be banned. This comes very often from like from different bank, different credit card companies, a different website where you have some access to the financial data. So this can happen, but it's a literal phishing email. It's a easy for AI because why? Because it was quite using a quite traditional way. Like your account is locked. So first keyword is locked. Third is the immediately is the urgency, and fourth you'll be banned is a negative word. That means they are threatening you. So it's easy for AI. Now if you look for the example two, now the hackers are getting smarter. So they are trying to put sarcasm inside this. So they have sent you an email like, oh, great job. You managed to crash the server again. Click this to see the employee of the month award you just own. And if you work in a company, for example, and if you see this email, you thought that you must have arranged some techniques to 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 report the crash of the system or the server, or you managed to protect that your server from a crash. You must be getting this from exactly same email ID, exactly same person you are dealing with every day in your company. And this kind of thing, the sarcasm is hiding behind it. Like when we say, oh, great job, you managed to crash the server. So here, you managed to crash the server is a negative word, but a positive sign is attached towards it, like, oh, great job. So AI can only understand that why, what is the probability of this, and why it is constant as a negative intent. So if you see the first example, the sentiment here is negative, yet threatening. The intent is fear. That means they want you to get in fear. But the AI detection is very easy here because the words are quite obvious. But in the second example, we can see the sentiment is a positive words like great job, award, winning. So these are the positive words. So anyway, AI should fail. But if we apply the sarcasm detection inside the NLP, inside the AI-based malware intrusion detection algorithm, we can find that it's actually mocking. It can be a negative tone. So we have an intent of shaming or curiosity. So if you have a curiosity or having a shaming, you should click this and then you are done. Whatever the intent they had, they have successfully crashed the system. So that's the thing that we work on. So in our lab, we have developed a sarcasm detection algorithm to find this kind of malware detection. So generally, we have used it in some other application domain, but if you are interested, we can apply that into the malware detection algorithm. Also, we have the model ready. So we have proposed a two-stage deep learning based algorithm using a first text and by LSTM. LSTM is a long short-term memory. So it's a complex models you can see like that, where we can see that how the semantic contiguity in the news of the text is actually helpful for finding the sarcasm or finding the malware. So how does this contextual incongruity works? So that's the main challenge of the sarcasm. So for example, if we take the second statement, that is a great job destroying the server or the great job crashing the servers, and how it will work. If we contain this thing into two parts, first part is a great job and the positive polarity will be high. And the second part is destroying the server or crashing the server. That's a negative polarity. That is -1. So when we have equal weightage of positive polarity and negative polarity, there is a conflict. And when there is a conflict, the model detects a flip in polarity within the same sentence. So that's a very tricky part, even in the advanced algorithms. So we have developed an algorithm here which can detect the malware in terms of other application areas, obviously, and work on this system to find the intent or the hidden sarcasm, and that has achieved of around 97% accuracy. So high probability of sarcasm is there. Intent is likely malicious despite the positive words. So you have to be very careful why you are dealing with this kind of scenarios. So beyond keywords, so these are only talking about keywords, like when we have keywords like great job, destroying, crashing, threatening, different kinds of words. So what about if they don't use the word? We have to rely on a BERT model. So BERT is a transformer-based model. So in the transformer model, we have some kinds of encoder, we have some kinds of decoder. So GPT is a BERT model, GPT is a transformer model. So why I'm talking about the GPT? GPT is the basic background of the chat GPT, Gemini, and all these things. So GPT tried to have a decoder and encoder both, and they use as a BERT in the background. So when we have any kind of transformer model, so why do we need that? Because when we have no access to this kind of keywords, which are widely used as positive keywords or negative keywords, our basic ML algorithm fails. Then we need a transformer. So what is the benefit of using a transformer? Transformer can find the difference between a bank of a river or bank account details, or it can find the difference more funny way that it can actually find the difference between a state, maybe Reserve Bank, and maybe Bank Ganga Bank. So it can find the difference that if the bank of a river, it does it mean, or does it mean a financial bank? So this kind of scenario is very helpful. So we need to understand the entire context. So does that bank is a financial body, or does the bank as a side of any streaming river? So BERT model can understand this context. In the malicious URL detection, we can use this BERT model, but there is another kind of algorithm which is very useful for malicious URL detection. So this kind of URL these days are very widely populated in terms of SMS. Sometimes we get SMS or WhatsApp messages of clicking on a link, and those URL are completely being formed in terms of a real one. So Facebook has been written in such a way that if you look quite inside, then you will see that in the Facebook, the C is also the E. So it's like FAEE, then book.com. So it looks completely different in the same font, but slightly different. So in normal human being cannot detect that. So we have a specialized soft algorithm for that. We call it DGA, domain generation algorithms, which try to find this kind of bots developed URLs, and those random domains are easily detected as a malware. So we treat the URL as a series of characters. So for that, we need the support of an AI algorithm. And what AI algorithm is this? Is this RNN, recurrent neural network. So I talk about the LSTM. So LSTM is a long short-term memory. So it is a different form of RNN. So RNN is umbrella topic. Inside the RNN, we have different kinds of uh, uh, different kinds of algorithms. LSTM is one of that. GRU is one of that. So when we have the recurrent neural network, why it's recurrent? Because you try to find the last keywords again. When it is fine to find the Google and then security, try to remember the Google as well. So it treats every single part of the URL as a sequence of characters. And AI detects this randomness or lack of linguistic structure in the domain name. Next comes the SQL injection. So when we have a SQL statement, for example, select star from the user where name equals to admin or 1 equals to 1. So to a human being, it looks suspicious, right? So generally, the spammer or the hacker do not give this kind of SQL injections, but it can be a quite advanced form. But still, it looks suspicious. So when we have a input fields where expect names, like for example, we are expecting a name like John Doe, but instead of that, we are expecting a name like admin. And if the input contains any kind of or equal to, or semicolon, so we have all these three here, and the NLP model recognizes it as a linguistic anomaly. So NLP does not require to learn the sequel entirely, but it can find the sequence of the characters being used and try to find that it must be a foreign language in the name field. That means this sequel injection, uh, I I cannot allow it to play. I cannot allow it to inject. So there it can protect the system from these SQL injections. So that's another way we can use the transformer model to use in the SQL injection. Log analysis is another concept where we have, like as I told you, like we have generating like trillions of text data every day, and we have like terabytes of data being generated. And with different data being generated, there is a log being generated. Like if you log into the Facebook, if you scroll, if you've seen hundreds of reels, if you have seen thousands of comments, and many things you have run so far. So where this entire data are going? These entire data are being saved in some server in the Facebook, and these are saved as a log file. So maybe we have just opened the Facebook app and scroll it randomly, go to some reel, go to some other reel, go to their profile, see their other photos, see their other posts, go to the comments, and entire these things are being recorded. They are recorded not as in visuals, but they are recording as a log, like that like the user X logged in, the process Y started. And this log analysis is a big chunk of data, and millions of text of logs are saving. And how to deal with that? So if we have any kind of traditional algorithm, it fails to look into like millions of text logs for a single user. But if a user is a spammer, if a user is someone like who has just logged into your Facebook system and they have just get into your page and going to some friends, unfriend those things, those people, and then go to your post and randomly deleted few posts, this entire process or the entire sequence should be looked as anomaly. So AI can detect that. AI can, if the AI sees that user X has logged in and immediately they have deleted some file, for example, deleting a post in terms of Facebook, visually it's a post, but actually it's a file on the server, delete the file, then that means there's some kind of anomaly has been happened. And the Facebook should take action immediately and send a notification to your connected email and the phone number that we have uh, identified some kind of anomalies. And if this is you, then confirm. If this is not you, please change your password immediately. So this kind of things, AI-based malware detection can only work. So that's the end of the part 2 of the NLP-based applications. Now, when we talk about we have finished the computer vision. Now see how we can convert the data into images and then work on it. Then we have seen how the textual data can be handled in the NLP way. Now we are talking about the anomaly detection. That is the actual health approach in terms of cybersecurity. So in terms of trying to find the anomalies, because we are not talking about the traditional anomaly detection here anymore, because traditional anomaly detection or the outlier detections fails to work on the recent developed spamwares, because they cannot identify those patterns, they cannot identify the trends, they cannot identify the hidden signatures. So we need the power of AI into this. And most of, I mean, 99.5% anomaly detection algorithms runs today on any of the big servers are AI based. So when we talk about the AI based anomaly detection algorithms, there can be two kinds of approaches. One is a supervised learning approach, another one is an unsupervised learning approach. So supervised learning approach, in simple terms, if you're not aware of AI, supervised learning approach is somewhere where we have the knowledge of the data, we have knowledge of the labels already, and we know which is spam, which is not spam, and we feed our machine learning model or deep learning model with those information to have a knowledge that yes, if you see something like this, flag it as spam. If you see something like this, flag it as ham. So when we can't identify spam and ham easily, we call it as a supervised learning, and that's only possible when you have the pre uh, predetermined levels. So, but why supervised learning algorithm fails sometime? Because it fails on the zero-day attacks. So as I told you, the zero-day attacks, these are very dangerous because every single day, 450,000 new kinds of malwares are generated. And in the zero-day attack, if they have changed quite a bit of the malware, like not only changing a single bit, but changes a huge portion of the malware, the AI can also fail in that scenario. And there we require the part of the unsupervised learning algorithm. So unsupervised learning algorithm, instead of storing or learning the part of labels, learning the part of the data sets which looks normal to them, it try to find the patterns, it try to identify the anomalies, it try to find the trend and compare it with the normal signals. So what is the fine difference here? So supervised learning algorithm try to learn from the viruses, from the spamware, from the trojans. And unsupervised learning algorithm try to learn from the uh, less noisy data, from the safe data, from the benign data, from the safe signals or the how can I say, like benign signals. So it can work on in that way. So when we are learning from a good thing, like for example, we know, like just for example, you are developing an cardiovascular detection system and you are trying to develop on based on the EEG data. Now, instead of having thousands and thousands of combinations of changes in the heartbeat, what you do, you try to train your AI model in such a way that your AI model is able to find a normal heartbeat or normal cardio rhythm. So when you try to find and generalize the normal cardiac rhythm, it can easily find any single or slight changes in that cardiac rhythm and then flag it immediately. So that's what the unsupervised learning is powerful. And it is also capable of detecting the zero-day attacks. Now, how we can work with these unsupervised learning algorithms? We have the autoencoders. So autoencoders are a combination of encoder and decoder twice together. So we train the network not only on normal traffic, it learns to compress and reconstruct the normal data perfectly. That first, it takes the normal traffic, it try to learn the normal pattern, try to understand and uh, memorize and learn all the signature in the normal rhythm, and then it try to compress and reconstruct the normal data again into a decrypted data. So when an attack occurs, the network fails to reconstruct it, and that causes the high error. And when we have a high error, this means some kind of anomaly is there, and there what the autoencoders find it and flag it immediately. So in that scenario, what will happen with the IoT devices? So when we have a IoT device, and like it can be any kind of IoT device, like the devices that help you for like drone, that help you for like agriculture, devices help you for like healthcare analysis. So these are being generated using a bot, and IoT botnet detection is a powerful tool for that. So for example, if you have an IoT profile or if you have an IoT device where a small smart bulb is sending a small data package periodically, that means a small bulb is there, a small LED bulb, and if you pass on like through the bulb, there is a single blink and it will send you a signal in every 1 second or every 2 seconds or 5 seconds. It's a very predictable way. Now, how we can find this attack? And the attacker can bypass this very easily. They can pass through the bulb when there is a off time. Now, how to detect that? So if we have a Mirai botnet, like a kind of bot or AI bot or maybe any kind of uh, bot, it takes over and sends a massive DDoS signal. So DDoS is a very dangerous thing. So it's a distributed denial of service. So if we have a massive DDoS traffic and suddenly we have the signals been broken in a slight millisecond, so it is completely undetectable for a human being, for a maybe any kind of anomaly detection algorithms. So how can we predict that? How can we detect that? So it can be identified using a volumetric anomaly. So if we have a huge number of data, for example, we are training on those smart bulbs data for periodically getting signals like for years and years, even for a few months, the AI can see the spikes in the data volume that deviates from the learned health and from the unlearned features. Unlearned features means the features which are not being learned yet. So that means some kind of anomaly is there, and then it flagged. So we do this research in cybersecurity. So in our lab, we work for this IoT-based thing for the Alzheimer management. We work on the medical IoT security. So how it works? So if a patient's data is being generated, like blood pressure, oxygen level, pulse rate, movement, their postures, their other facial features, these are being sent over an wireless signals like can be Bluetooth, can be Wi-Fi signal to the entire cloud server. And this entire data is being stored there in the server. And once we have those servers with us, we can analyze and update data by any medical experts. Now, these medical experts are unable to detect any kind of cybersecurity attack because they are not people, they are not computer scientists, they are not the security expert. They cannot identify that. But we can have a high risk of breaches here and here. Now, what is the risk? So when we're transmitting a sensitive biological data, for example, their location, their blood markers, their biomarkers for the disease, anything. So when this data are being transmitted to the unencrypted channels, what will happen? Maybe some spammer or the hacker can get those data and like they can disturb the person. They can use that data in some different way or in a bad way. So there's a high chance of low power sensors also, which can often uh, cause robust encryption. So we have a system here where we can breach this breaches in such a way that we can keep those data being transmitted, but still we can secure the identification of the person or the patients with us. So it's a quite advanced and the quite fascinating thing to think about. Like we cannot we share the GPS location, we share the RFID code, we share the infrared sensor data, but still we can secure those things. So we can do these things in terms of different hammer spoofing, or we can use a blockchain technology to detect that. Another part of my research deals with the UAV security, so unarmed aerial vehicles, where we are using the drones. So these days, drones are not only using any kinds of like remote control, they are completely unarmed. So they can move around the different locations with their own GPS signals. And these GPS signals are actually causing the GPS spoofing. So if a drone starts from here, and if it goes here, it goes here, and it tracks every single signal with a satellite or maybe the server that it connects to, and the signal generator is here, and we can any kind of attacker or the hacker can easily spoof into it and find the location of the drone. And once it finds the location of the drone, it actually track it, enable it in your own spamware, and just grab it in its own way. So what is this GPS location? So we can use a secure flying internet. So why the secure flight internet is important? Because we can chain this package or the package of data or in terms of GPS location sending, in terms of any kind of information sending, in terms of like the sending the signals in real time. So we can send this using a blockchain integration. So it can create a secure decentralized system. And when it's a decentralized system, we can easily access without accessing uh, the the confirmed location. So that's we means the hackers over here. So if we have a swarm of UAVs running over here over the city and hundreds of UAVs are running over here, we can create a blockchain based server here and it would connect to the cloud networks, and the UAV can still help in the remote locations. So if you want to work on the anomaly detections with the AI, there is lots of algorithms and the data sets are available. So I would suggest you again for your students or maybe you yourself to work on these data sets. So if you look for the Kaggle or the GitHub, hundreds of data sets are available like NSL KDD data sets, CIC IDS data sets, and these are very important data sets like the IDS 2017 data sets. It has huge number of DDoS and brute force attacks to be identified. So quite good for you to start with the AI-based applications with this data set. So now the end of the part 3, that is analyzing the health for the security. Now we are going upside down, as I promised you. Like we are trying to become the dark side of the spammer. Like it's called the adversarial AI. So when the as we are leveraging AI for saving the cybersecurity, we are trying to use the AI to protect our network. We are using AI to prepare the secure system. We are using AI to build strong malware detection algorithm. Then why not hackers use that? Hackers are again using the AI, and that's the biggest dark sides. Let's talk about that. So it's a very famous example of a panda. We can see in the Goodfellow paper in 2014, where we have seen that a model can be AI model can be fragile sometime. And even adding an invisible noise to an image. So when I'm saying an invisible noise, it's really an invisible noise. I'll show you in the demonstration today how this invisible noise can cause AI to misclassify an image with high confidence. And this kind of scenario, we call it as an optical illusion in cybersecurity. So when we have an optical illusion, so we can get confused between a malware and between a uh, benign signal. See, if we see here, it's an image of a panda. And when we have no malware or no virus been injected here, our AI algorithm, what is algorithm? Algorithm is a malware detection algorithm, is actually depicting the picture as a panda with 57.7% confidence. We are not looking into the confidence index, but it is detecting as a panda. Now, when we introduce a very, very slight noise is like 0.007% noise. So can you imagine how small is this noise is? If we introduce a 0.007% of the noise into this image, and that's the final resultant noisy image, which looks exactly same visually for a human being, which looks exactly same for an AI, but that's a gap within AI. So why we can do that? So if a hacker uses an AI techniques to manipulate the image in such a way that AI algorithm may fail to detect as an spamware as a spamware, so we need to work on that as well. So we need to work on adversarial attacks. See, for panda with addition of a slight noise become another image which looks exactly like a panda, but our algorithm is stating it as a given with a 99.3% confidence. That means they are so confident being it as a different object. So that's the optical illusion for the AI as well. So what kind of attack they do? So we have the malware evasion. Malware evasion is like adding some junk bytes, small changes in the bytes, like some changes with 0, some changes with 1 into a virus file. And that's quite difficult because there are thousands and thousands of lines of codes. And if we change a few bytes there, it's quite difficult to parse the entire thing during a real time uh, uh, follow up of the malware detection. So what is the effect? So the virus functionality is unchanged. So that means even if we change some bits, the virus is still a virus. It's still the same harmful as it was, but the visual texture changes. So that where what we can help it? We can help it with the computer vision techniques that I just explained you in my part 1. So here the computer vision techniques can only identify the changes, the slight to the slightest changes in the visual texture and map it or flag it as a spamware. Next is the generative adversarial networks, or we call it as a GAN. So generally, the GAN networks are used to generate the synthetic image. Now, the AI hackers, I call it AI hackers because the hackers who uses the AI are using the GAN networks to create the viruses. It creates some fake malware variants to bypass the detection and then try to detect the fake malware. So what will happen? It uses this as a loop to create the entire scenario of a malware and malware detection, and that can guarantee to bypass the AI defects. So that means it is not creating a malware, it is nowadays creating a super malware. So super malware is a malware which have been generated, which have been passed through a malware detection algorithm, learned where it has a glitch, comes back, again update it, goes to the malware detection algorithm. If any kind of glitches are being caught, then again it comes back and trained again. So in the process of this, again, AI based or the GAN based network, in the entire loop, this malware becomes super malware, and it can bypass the current AI defenses as well. So that means even we have the strongest AI based malware detection algorithm, it still can fail the advanced AI based malwares. So that's the where you have to work with. So you have to work with strong AI expert. If you have cybersecurity expert, develop the malware detection algorithm in such a way that AI-based malwares or the super malwares can also be detected. That's the new challenges. Another challenges is the defects. That is the social engineering challenges where we have like AI generated audio, video, or sometimes some posts, some photos, some videos are quite misleading as a truth. So we need a defect detector also to fight the AI, because it's a new challenge and it's a new kind of crime that has been happening. So you can also work on this social engineering. I call it social engineering 2.0, and it can uh, be a new area of research in cybersecurity. Another concept that is quite popular these days is called as a boiling frog syndrome. So what is boiling frog syndrome? So boiling frog syndrome is like similar to the GAN network loop. So if an AI learns continuously from a network, the spammer, the hacker who is developing the spamware, who is developing the malware, can slowly inject this malicious traffic label as safe, and over the time, the AI drifts and accept the attacker as normal. So that means they're becoming more and more like they're becoming smarter because the AI learns continuously from the network. So if you have a learning system based on the network, and the different signals passes from one direction to the another direction, and it learns from the patterns and learns from the pattern in such a way that there is a consistency of injecting the malicious traffic as also as safe. And over the time, the entire learning scenario drifts, changes, and sometimes it accepts the attacks as also as normal. So that's also the danger thing. So we call it as a data poisoning. So be sure about that. So one is a GAN, second one is a defects, third one is a data poisoning. So these are the areas that you can do research because it's still not yet complete, or I can say still not yet being developed. So these are the things that I told you about this things that being worked on. But in the future, you can also work on some federated learning algorithm. So this is a scenario which we are already started working on in the federated learning. So what is federated learning? It's like training the model, training the AI model with the spamware or the malware detection signatures, send those signals to a centralized node, but in a more secure way. How to make it secure? Instead of sending the signal as a human or AI enabled signatures, what we can do, we can send only the mathematical weights or the updates of nodes to the central server, and the central server will try to decrypt it again, and they can find the receiving model, which is we are securing in the node 2, can detect that. So we call it as a privacy preserving AI, and federated learning is a future, and we cannot deny that because these days the bank, mostly the hospitals. So most of the UK hospital is also using the federated learning approaches for their AI-based applications because they do not send, they cannot now rely on the pseudo-anonymized data. They are securing the data with the what we are working with the NHS in the UK. So they are trying to secure or preserve the entire privacy with just sending the mathematical weight to the different nodes. So that's another way you can work on with a federated learning. Next is the explainable AI, where you can use a Xi model like SHAP, LIME, Xi model to find and explain uh, the model or the features that you are being capturing or the alerts that you are being triggered. Another process is the tiny ML. So I'm telling you these things as a different domain for you to do the research. If you're interested, you can reach out to me so I can also help you understand this better. So another one is a tiny ML that we are. It's challenging because tiny ML is a concept where we are trying to develop a deep learning algorithm inside the IoT sensors, and sometimes these IoT sensors are very very small. They have very limited power, so we cannot run TensorFlow inside the Raspberry Pi, but we can run mini TensorFlow inside the Raspberry Pi. So if you can develop a tiny ML or tiny DL algorithm inside the sensor, then instead of sending the signal directly to the drone or UAV or the node, it can bypass those and uses a federated learning approach and send the weights only, so that you can secure your sensor, you can secure your UAV or drones. So and the next process is the blockchain and the AI convergence. So the first thing is the data integrity. So we can use a blockchain because blockchain is getting popular and was popular also, but now is getting popular for securing a decentralized model to securely bypass or uh, the bridges and passing on the data to different nodes, so it can store hashes of trading data as in forms of blockchain to prevent any kind of data poisoning. So we are also in our lab, we are also working on blockchain based secure IoT networks so that we can enable AI and blockchain together, and it's a good convergence. So we have a research in our lab, so where we have introduced a new or proposed a new algorithm where neuroscience, IoT, and blockchain are being adapted in a way. So we call it as a neuroadaptive incentivization, where you use the IoT to monitor the health and the behavior, and use the blockchain-based smart contracts to release those incentives, like small tokens. And we adapt those rewards based on users' neuroadaptability to give them some kind of incentives in terms of motivations. So we are working on that as well. So this is a quite good area of research. Another one is a dark trace, which uses the enterprise immune system. That means it uses unsupervised learning for each and every devices. So I'll show you three different research questions for that. First is how you can work on these areas that I have just shown you. You can use these three research questions for your research. So first question is to check the robustness. And the question is, how do we defend AI against the adversarial attacks? Then for the privacy, you can have the research question like, how do you train those encrypted traffic without decrypting it? And this is the most important and challenging part, the privacy. Because if you can solve these research questions in any of the domain that I have shown, it would be a very generously appreciated paper on high impact journals. And third research question that I can help you with is in how do we run these huge models in a real time scenario, or maybe we can use tiny ML or something like that. So how do we run these models in a line speed? Because in a real time network runs in 100 Gbps, even more. So how can we run this AI model on that? So this is a quite optimistic, but you can work on robustness and privacy. So basically, you don't need anything to learn. If you're not from the AI background, you don't need much things to learn. You just need to learn Python. You just need to learn TensorFlow, Keras, or Torch, and you just need some data set to start with and some algorithm to work with. So I'll show you today the a short demonstration like how it works. So by my vision as an AI expert, as an AI scientist, is that in the future the network will act like a biological organism. So why I'm talking like a biological organism? Because when we have something happen to a biological organism, for example, some kind of rashes there in the skin, some kinds of uh, marks on the skin. So what will happen? It will try to heal it itself. So if we have a self-healing network, if we can develop, it's optimism, it's optimistic approach. But still, if we have this vision, having a self-healing networks, we can stop all these things. So network will definitely look like a biological system where it will sense a pathogen, that's a virus, malware, trojan, or anything, isolate the infected tissue, like what it does, that is a server, and it generates the antibody automatically. And here antibody means the patches to heal those connections, to stop those spamware or to enable those connections again in a healthy way. So cybersecurity is a great frontier for the AI researchers. So if you think that I'm a cybersecurity researcher, I don't need to learn AI, I can tell you in the next 50 years, there is the entire scenario of AI. You cannot bypass AI anyway. AI, if you think like we have GPT-5, we have Gemini, High, and it is working like a fantastically, but it is just a starting bug. So if we think right now, AI is like a tip of an iceberg right now. So it is developing and it is right now in a baby stage. And in the next 50 years, AI will revolutionize everything. So if you want to develop your skills and develop your research in cybersecurity, you have to rely on AI right now, and you have to learn the AI. So that means I generally say like if we have the machines, if we have the data, then we just need to understand the patterns, because unless we understand the patterns, unless we understand the signatures, we cannot understand anyway the anomalies. So these are the key references, so you can read these papers. These are fantastic papers, and some further readings are there. If you have the questions, so we do not have the process to have a verbal questions here, so you can drop your questions. I can see and try to reply you back. And if you want to contact me, here my LinkedIn address, Instagram address, and my website. So I'm open for collaborations. If you have any questions, you can drop it to me. You can take a screenshot right now so that I can quickly move to the demonstration of the code. So I'll wait for a few seconds if you want to take a screenshot. Okay, so I will now go to the code that I have developed for you. So I developed a code for you. If you want, I can give you the code to run also to check, and like a toy example. So I have defined each and everything here, like every steps I'm using. So the first thing I'm trying to run the simple Python libraries that we require. Here I'm using a TensorFlow because I am using a convolution neural network. So I'm using a TensorFlow, but you can use a PyTorch also. It's up to you which platform you want to use, PyTorch or TensorFlow. So maybe I can zoom it a little bit if you want to. Yes. Okay. So first we'll work on the vision. Second, we work on the NLP. Third, we work on the health. Fourth, we work on the adversarial AI. So this notebook will help you understand the entire PPT. So we have loaded this or import these libraries. We have used the TensorFlow. And then first we are going into the part one, that is a vision approach. How we can convert these viruses into images and then work on it and as a computer vision approach. So we can develop two ways. Two things. One is a benign signal and one other one is a malware signal. So first we generate some synthetic malware signal. So in the synthetic malware signal, we create some benign here. So in the benign signal, we try to create in such a way that it is randomly generated, but have a very, very small slight noise, like 10% noise we have added. And we have created the malware signal with some completely random noise. So much noise over there. And we try to visualize the data. So we create the data. We have a class 0 that is a benign, and we have a class 1 which is a malware. So malware have a high entropy. That means it is very noisy. So we have used 10% and this is completely like 90%. Now we build the convolution neural models. It is a deep learning model. So we create the model here. We have used the input signal as 28 pixel and 28 pixel. That is a number of nodes. And there we have used a 2-dimension convolution layer. And we have done a 2-dimensional pooling layer. And then we have a single layer of fully connected layers with activation function ReLU. And finally, it's a binary classification, spam or ham, spamware or safe. So we're using a sigmoid function here. So we have trained it and we have run 30 different epochs. And although the result looks very good here because it's a randomly generated image, if you have a real data set, you can just drop the real data set here, use the same code, you can see the real data, real change in the results. So forget about this accuracy. Just ignore it because it is always good because it is a simple results. But you can see the loss function here. The loss function is changing and it is decreasing. You can see it's decreasing from 0.38 it started, it going to the point 0.000015. So it is decreasing quite well. That means our CNN algorithms is working fantastically. Now we evaluate this result. Now we see how this result works. So if we use a confusion matrix right now, we can see that for this model, we have identified all the benign signal as benign and identified all the malware signal as malware. So there was no false positive and false negative results. We have all true positive and true negative results. This is unrealistic in real life when you have real data, but I want to give you a structure or architecture to work on. So if we change this data right now here, so instead of having a 10% noise, we added here 80% noise and run the program again. And it will take a few seconds to have like 30 epochs. You can have 300 epochs when you have time at your home. You can finish the 30 epochs in a few seconds. Finishes. Now you see the error is higher. First time it was 1.5 to the power 10 to the minus 5, but now it is 2.6 10 to the minus 5. That means the error is still high. So when you have less noise, the error is less. When you have higher noise, the error is high. So that means we have to keep this as a less noise. So, but you can change it. You can change the amount of noise you are adding. Next is the NLP approach. So we can it's very difficult to load an entire corpus right now to show you the demonstration, but I have taken a few examples from the famous corpus where we have the emails with the tagged emails where we have the labels of this is ham, this is phishing, this is ham, this is phishing. We have the emails like meeting rescheduled to 3 p.m. in conference room, urgent, your account is compromised. We have just loaded a small toy examples and then we have converted into vectorization and we have run the NLP model. Once we run the NLP model, trained on this email and now see if it can identify the data. It can identify clearly the keywords which are actually triggering the phishing alert. So if these keywords are actually inside the inside the email, then there must be email can be flagged as phishing. Next is the part 3, anomaly or the UAT. So when we have a UAV or IoT devices, maybe just considered as a sensor, we work with unsupervised learning. Why unsupervised learning? Because the sensor generates random data and it is completely unpredictable. So when we have unpredictable data sets, we cannot rely on a labeled data set. We cannot rely on supervised learning. We have to be a, a kind of a smart system with a pattern analyzer. So here we are using the unsupervised learning. We are generating and collecting the data from the IoT and UAV. So we are generating 300 sample of data and we are having a cluster size of 0.5, and we are adding some noises here. So the contamination here is 0.1. You can add and change more and more contamination here. And you can change the noises here. So I keep it -2 and 2. So that means if the data is here, the noise will move until the +2 and -2. You can increase the size, you can decrease the size to see the changes. So you can change this 2 and -2 number, you can change the cluster size, you can change this contamination. You can see the changes in the results. So if I run it and apply my health algorithm, you can see that all these green dots are featured as a normal IoT traffic or normal ham signals, and these red zones are all required as spam. But we can see here that some of the signals are quite close, but if we change the data here, if we have a maybe contamination of 4, and I mean the data size of 4 here, if you run it again, if you run the algorithm, you see now the cluster is more dense. That means it can capture the spam signal better, I mean, and the ham signal better. So all the red crosses are detected as an anomaly right now. These are clear anomalies, but finding these, which are in a vicinity of the ham signals, are quite difficult. And now the last part, what is the evasion attack that I showed you in the adversarial AI, how the AI hacking of AI works. So now we have to develop a spamware. Now we are going in an upside down process. Now until now we are protecting the system from spamware. Now we are developing a spamware, developing a virus, an AI enabled virus. So we create an adversarial pattern right now. We randomly create some images and we have some gradient clipping over here. So we select a spam malware sample here and we verify that whether this entire thing is a definitive malware or not. So how to do that? First, we create the attack function, then we apply the attack. If we apply the attack, it says that it's 0.2% chances that the model thinks that this malware is safe. Now, why it happened? If we have a high epsilon, that means our AI-based malware is so strong that it can bypass the AI algorithm and the malware is considered as safe. So we have to reduce the epsilon here. If you reduce the epsilon here, maybe 0.1, says that this is 99% time it failed. So that means now the malware is not breaking the system. That means malware is not quite AI enabled. So we can visualize this attack as well. If you see with a 1% thing, so originally the malware or 100% malware that we have already created a malware. So and the malware looks like this, and we added some noise. Noise is like AI based noise and some overlaying of the AI, and this noise is a new attack, and we overlaid on this malware. And when we run our AI algorithm, it bypasses, and with 100% accuracy or 100% confidence, our AI algorithm is considering this malware as a safe, but it shouldn't be. So that means this is a very small toy example. So in a large scale, if we change this epsilon, we cannot do that. Maybe the hacker can do that. So if the hacker can change this epsilon and they can make the malware so strong, AI-based malware so strong that they can easily bypass this AI algorithm. So that's all from my side for today. And I can share you the Jupyter notebook if you want. You can reach out to me if you have any questions. Thank you so much.
Thank you so much, sir. That was really very knowledgeable. And please do share your notebook. That would be really helpful for us in our research work as well. Miss Urvashi has a query, sir. I'm giving her the mic permission. Urvashi, ma'am,
Hello.
I have given you the
Hello.
permission.
Yes,
Yes, ma'am.
ma'am. I thank you so much. Sir, I have a query. I am working on the zero day attack detection in the IDS part, and I'm trying to incorporate the blockchain technology in that. So could you help me out? And like, I am not yet decided the methodology. So should I purely focus on putting down the unsupervised algorithm, or like supervised plus an unsupervised should be recommended? Like, is it
Yes,
recommended?
I can get your question. Yeah. So we have the second part that you mentioned is a semi-supervised learning. So
Mm-hmm.
semi-supervised learning sometimes is quite helpful in the scenario, but still, if you're trying to build a model completely based on this blockchain technology, so I would suggest to just rely on unsupervised learning. But still, if you want, you can apply for semi-supervised, which is a mix of supervised and unsupervised. But unsupervised learning is better here, from my experience.
Okay, sir. Thank you. And what about the deep learning part? Unsupervised deep learning would be better as compared to the unsupervised machine learning, right?
Yes, if you have a large amount of like malware data, if you have a large amount of informations in terms of dimensions, then definitely you should try with the deep learning based unsupervised learning.
So,
So it's betterly, yes, tell me.
so where can I have the realistic data on which I can try it out? Because right now I have been working on the NSL KDD and the CIDs. But
Yes,
from where
that I
can I
just
get?
mentioned in the slide.
Yeah. So where can I get the realistic data so that I can try out and that could be more effective to
See
prove my.
what the biggest challenges we have right now. The most of these spamware and these data are not public yet, and that's not public yet due to the different concerns like because the spammer or the hacker will understand like what we have detected so far. So and the developing a new data with a synthetic way is obviously I don't like you to do that, because synthetically if we generate or augment the data, it's sometimes not useful. So I would suggest, like even I would suggest to my collaborators and the students, that what you can do, you can use a robust model, and that robust model should work on that small scenario. So it's instead of like increasing the data, it's like a microscopic experiments. So what is microscopic experiment? For example, we have hundreds of millions of data, and we have hundreds of millions of data. We try to develop a model that can work on that data. But if you see that entire thing in a microscopic way, and we develop a microscopic model that can work on that particular data, if you have thousands of data, if we build a robust microscopic model, that for that robust microscopic model, thousands of data is a big data, right?
Yeah.
So if we can develop a robust model, if it works on thousands of data, it's fine. It's fine for now. And unless you get a big chunk of data, and I really don't know, because the most of the data that's are available online, like in Kaggle or somewhere, those are mostly sometimes synthetically augmented, or sometimes they are like already we have. So those are not enough. So I'm still working with many students right now, and the problem is a big chunk of getting a big chunk of data. I can understand your problem. So that's why we have to rely on the model side, like not on exactly specifying that we have solved this problem with developing a new technique to detect the malware, but instead of proposing that we have developed a malware detection algorithm, or IDS algorithm, where we can detect these patterns, small patterns. So these patterns, if we can convert into microscopic or macroscopic, the patterns will be same. So just concentrate on developing the deep learning based model that can identify those unseen threats in the data or the signal.
Okay, sir. Thank you so much.
Thank you.
Thank, thank you, Rishi ma'am. Next query is from Miss Sonia Batra, sir.
Uh, Hello, sir.
Hello.
I am particularly a research scholar in the same domain, working on malware detection techniques itself. And I just wanted to ask one question. What are the very less explored areas in case of explainable AI techniques, when we just talk about explainable AI in case of malware detection and summarization? So could me please guide me up on these ones?
Sure. So I don't remember all the unexplored area because for understanding the unexplored area, you have to explore the literature. So once you explore the literature, you can understand like what are the gaps that has been left behind, what are the things that have been left behind. So there is no list of unexplored areas, but one thing is very important. It can be incremental research, it can be a new research. But when we talk about the explainable AI or XI, in particular terms of malware detection, it's like how you are signifying or denoting a particular malware as malware. So that means when a system, it can be a machine learning based system, it can be AI based system, it can be generic traditional system, but when you're signifying some malware as a malware, try to find those threats, and those threats, how did you find those threats is very important to save those weights. So uh, so it's not important like, or it's not important like what are the different uh, unexplored areas, because Xi is itself completely unexplored in terms of malware detection, because we have lots of malware detection algorithm which can denote a malware as malware and not malware, but most of the malware detection algorithms still cannot tell us like how we find those malwares, and that's very difficult when we have a deep learning based framework, but that's what we need right now. So just work on the Xi model right now because it is still unexplored, and work on the Xi model and try to find the traits inside the uh, or the patterns or the traits inside the malwares that you want to find, and exploratory analyze that why the traits are considered as malwares, and then visualize those things or maybe plot those things as a SHAP model or line model. Okay, so there is no such open research because Xi itself is an open research area.
So I do think it's a new research again instead of an incremental, if I think about. Can I
Definitely.
treat it? Yes.
Definitely.
Okay.
If you can prove it, if you can like, it's like unboxing your box, you know. If you have a model, if you can unbox it, if you can unhide the capabilities of your model using a Xi techniques, if you can show that how our model is so powerful to finding a malware as malware or a benign as benign, because true positive and false, true negative both are important here. So it's obviously a new research.
I use a synthetic data set or a existing data set will work more
Yes, you can
appropriate
work on
on.
existing datasets because when you use a Xi model for verification or validation, you may require the label dataset, right? So for the label dataset, you may rely on already available data that are available openly online. But I personally do not suggest to use a synthetic data because when you use the augmentation, it generally like from my way of research, we generally increase the noises more and more. So I know, a lot of people are using the augmented data set. A lot of people are using a synthetic data set. That's fine. If you want to revalidate your system, then you can use a synthetic data set. But to train your model with just hundreds of data and then synthetically increase into like hundreds of thousands of data, then it's not uh, quietly appreciable. Okay.
Thank you so much, sir. Thanks a lot.
Thank you.
Thank you, Ms. Sonia. Dr. Ritinder, I have given you the permission. Please ask your query.
Thank you so much, ma'am. First of all, thank you so much, sir. It was an excellent session. It was very informative. Secondly, sir, though I have worked with the data sets that you are showing, but my question might sound redundant, but is there any tool available through which I can generate these log files on my own and then use it for research?
We generally, yeah, we also do that. So it's not like
Okay.
that we don't do that. We also do that. So we generate synthetic data, but I told you it's not for the training the model, it's for validating the model. So I am afraid I still now I could not find any tool, but I suggest you do not rely on tool, just write maybe 5 to 6 lines of Python code that can like there
Okay.
is no ready-made tool as of now, I know, to replicate
So,
those
Matlab,
things.
there is no such tool where we can simulate an attack and try to extract the log
There,
files or a
there are
dump
tools.
out of
There
it?
are tools. There are tools to simulate the attack. There are
Okay.
tools to simulate the attack. I mean to say we don't have the tools or we don't. I'm afraid I don't know about any tools to like replicate the log files more and more synthetically
Okay.
that you can generate using simple Python codes. So, but attacks can also be replicated. Attacks can also be duplicated using like simple tools. Like tools means the Python code, but we in our lab we don't use any tools as of now.
Okay. Okay. Thank you so much, sir.
So,
Thank you, Dr. Itinder. I think, sir, all queries are done, and we are really thankful to you. And we really appreciate that you agreed to share your expertise with the participants. And that was really a wonderful session, and all queries were really handled very nicely handled by you. Thank you so much for that. I want to thanks to the participants as well. With this, we have reached to the end of our second session, and we successfully completed that. We gained valuable insights into the foundational role of AI in strengthening cybersecurity, and that was really wonderful. And I thanks all the participants to be part of the session, and I request them to please join for the third session tomorrow at again 6 p.m. And thank you so much. Good night. And thank you so much, Dr. Indranath Chatterjee. Thank you so much, sir.
thank you. Thank you. Good night, everyone.
Good night, sir.